Okay.
Okay.
Good morning, everybody. Good morning, everybody. This is the first part of the Geo4Agr workshop, and this workshop related to geomatics in forestry and agriculture, new advances and perspectives, will be divided in two sessions. The first one is this session starting now, and first of all, I would like to thank you, the authors, for their contribution to our workshop. We received 8 contributions, and we consider this very, very important for our workshop. And then I would like to thank the other organizers, Giuseppe Modica from University of Reggio Calabria and Marco Vizzari from University of Perugia. And in particular, please let me send my deep condolences to Marco Vizzari for his familiar loss for the father. This is the reason because Marco Vizzari is not able to join this session. So a special thought to Marco and to his family. Then we can start with our first part of the workshop in this session. We will have 4 presentations from 4 different authors and institutions involved in research and development activities related to geomatics and application of these methodologies to forestry and agriculture. So we will have during this morning a comprehensive overview of new advances, applications, and experiences in different fields belonging to the topics of our workshop. The first presentation will be that from Mirka Mobilia from University of Salerno. And Mirka will present a work with the title Evaluation of Meteorological Database Models for Potential and Actual Evapotranspiration Losses using flux measurements. In this work, they assessed the monthly scale performance of 6 meteorological database methods, and then they will present to us the results of their assessments and observation, considering different sites for land cover and climate condition. So I leave the floor to Mirka for the presentation. You will have 8 minutes plus 2 minutes for questions or other issues related to your presentation. Please, Mirka.
Good morning, everybody. Good morning, Maurizio. Can you see my screen?
Yes, I can.
Okay. Good morning. As Maurizio said, the title of my presentation is Evaluation of Meteorological Database Models for Potential and Actual Evapotranspiration Losses using flux measurements. I'm Mirka Mobilia from University of Salerno, and Antonia Longobardi and I are the co-authors of this work. Because a large number of models for the prediction of evapotranspiration exists, the choice of the most suited model is an important issue to be addressed. So this study aims...
I do apologize because
yes.
I'm interrupting you. You should switch to presentation mode.
Ah, okay.
Okay.
Sure.
Thank you, Mika. Sorry.
Is it okay now?
Yes, it's okay. Perfect.
Okay.
Go ahead, please.
Okay. So this study aimed at comparing 6 models for the assessment of evapotranspiration, which have been tested in 6 experimental sites. 3 of these models are generally used for the prediction of potential evapotranspiration, and the other 3 for the assessment of actual evapotranspiration. The case studies are 6 eddy covariance studies, which differ in terms of climate and land covers. The comparison of the performances of the selected models allows to provide recommendation about the most appropriate model to be used for the assessment of evapotranspiration and about the importance of the calibration procedure. The case study are 6 eddy covariance stations, which provide measured data of evapotranspiration that are available on Ameriflux, FluxNet, and Terreno platforms. They differ in terms of vegetation, specifically forest, grassland, and cropland, and in terms of climate, specifically oceanic and Mediterranean climate. The experimental data from these 6 sites have been used to compare the performances of the selected models. The 3 models selected for the prediction of potential evapotranspiration are Penman, Priestley-Taylor, and Ranick-Riddle models. The other 3 models selected for the prediction of actual evapotranspiration are advention aridity, Granger-Gray, and the antecedent precipitation index models. The corresponding formulation are shown on the right of the slide. 3 goodness of fit indices have been used to compare the observed value of evapotranspiration from the education to the losses of evapotranspiration predicted using the selected approach scale. The 3 indices are the root mean square error, the normalized root mean square error, the index of agreement, and the correlation coefficient. These figures shows that all the 6 models present similar patterns of evapotranspiration, but they differ in terms of magnitude of this variable. Value of the errors shown in the table that you can see in the top of the slide suggest that the PET models are less able to reproduce the measured value of evapotranspiration than the AET models. An exception is given by Priestley-Taylor model, which is best performing model for one site. That is the site number 1. Among the AET models, the advention aridity model is the best performing, and the APA model is the best performing only for one case. That is the site number 4.
Were distributed through the social media in order to gather opinions, expectations, and visions.
Sorry, can you hear me?
Yes, it's okay.
Yes, because I have another voice. Okay. And finally, the sites with the forest cover type and arid and semi-arid climate have the largest prediction errors. All the 6 selected models overestimate the evapotranspiration values. So a calibration process is required to have a better assessment of this variable. The parameters to be calibrated are the alpha coefficient for the APA models. This coefficient is originally set at 1.26. The relative evapotranspiration parameters G for the Granger-Gray model, which has originally the formulation shown in the middle of the slide, and the alpha coefficient and the wind function for the advention aridity method. The wind function has originally the expression reported in the top in the bottom of the slide. The APA model and the GG method require a one-step approach where the alpha coefficient and the relative evaporation parameters are relatively calibrated until reaching the best match between the measured value of evapotranspiration and the modeled one, which corresponds to the lowest prediction errors. The advection aridity method requires a two-step approach, where first of all the wind function is iteratively calibrated, but only during the most day, which are the day with a soil water content lower than 20%. Then the alpha coefficient is calibrated for the whole period, including the dry and the wet days. The monthly evapotranspiration fluxes provided by the calibrated model are more consistent with the measured value of evapotranspiration than the value obtained by the non-calibrated models. In the graph in the middle of the slide, you can see the differences between the error before and after the calibration approaches. The root mean square error decreases, the index of agreement and the correlation coefficient increase. Once again, the sites with the forest cover type and arid and semi-arid climate condition have the largest prediction error. After the calibration, the Granger-Gray models is the best performing method, so it is the most affected by the calibration process. In conclusion, we can say that in a non-calibrated approach, the advection aridity model is the best performing method. The model efficiency, of course, increase after the calibration procedure. Before and after this calibration process, the sites with the forest, land cover, and arid semi-arid climate have the largest model errors. After the calibration, the Granger-Gray models is the best performing one, and it is the most affected by the calibration. On the other side, the advection aridity model is the least impacted by the calibration, probably because this is a very complex procedure. It is require a two-step process. Finally, the result of such a study provides a recommendation about the selection of the most appropriate method to be used for the assessment of evapotranspiration in case of lack of data. Thanks for your attention.
Okay, thank you very much, Mirka, for your presentation, and also for your perfect timing, 8 minutes exactly. Any questions? I would like to remind you that you can also make a question using the YouTube chat, because we have also a live streaming on YouTube, and of course, if you want, you can use the raise your hand icon in the lower part of this interface. No questions? Okay, just a rapid question from my side, and considering the calibration procedure and the two different approach that you have mostly cited, which are the future developments on which you will be focused to improve the calibration and the validation of such models?
Okay, thanks Maurizio for your question. We would like to test more sites and with different types of vegetation and different types of climate and actually we are testing a new approach, an hybrid approach for a better assessment of evapotranspiration, an approach which couple potential and actual evapotranspiration models, depending on the periods, wet or dry months.
Okay. Thank you very much, Mirka. Thank you for your presentation and your work along with Antonio Longobardi. And then we have the next presentation from Sara Antonielli of Rigorous, a novel cleaning method for yield data collected by sensors, a case study on winter cereals. In their work, the authors focused on the development of a procedure easy to visualize and perform it in different contexts. So I leave the floor to Sarah to describe us their application and their activity in this context. Please, Sarah.
Sarah, please turn on your microphone.
Sarah, your microphone is muted now. Okay. Yes, we can.
Okay. So, hi everyone. And okay, I'm going to present work that we are going on, that is still going on, that is on industrial research actually. For this work, we focused on yield maps that are used by farmers to define the places where there is spatial variability of productivity and compare yield across time. This is very important for us because we are working on the development of yield estimation algorithms. Yield maps are usually collected, are derived by data collected by harvesting machines, and we are going to integrate in our decision support system, that is a software as a service platform that we provide to farmers, and that integrates data coming from different sources like satellite data, machinery inputs, data coming from in-field monitoring, and weather data. So in this context, of course, yield maps are very important to be added to this system. The point is that to integrate yield maps in our system, we have to face we have to manage different type of errors that are well known in literature, and that influences data collected by yield machineries, because they create a lot of local variability. They create a lot of points where yield results like zero, especially in the maneuvering areas. And they also can create some problems in the location of the yield itself. So for this reason, we are trying to find a cleaning algorithm for yield data that could also be industrialized. To this purpose, of course, we have to produce a robust model that can be used in different environmental situations, because our users are located all over the world, and that is also easy to industrialize. So it cannot rely on local knowledge, so it should be quite automatized and require just standard inputs and produce clear outputs, so not produce a very complex result to be interpreted, because our users are mainly farmers, not technicians, and can be also mathematized in an easy way. That's our purpose. To do this, we studied a lot of literature actually, but at the end we selected 5 papers and we analyzed them by the SWOT analysis that is typically used in economics, but in our case we applied it in a technical sense, because we focused on understanding the applicability of the different methodologies for industrial purposes. So we analyzed its strengths and weaknesses in terms of easiness to apply, easiness to industrialize, and also the opportunities and threats to apply the same procedure all over the world. The result is a procedure that is a mix of the different procedures that we analyzed, and it takes the main steps of these procedures. The first step of our procedure is the identification of null points. So in this way, we can identify all the points that are on the maneuvering areas and also the points where the harvester seems to work, but actually it wasn't working. Then we also focused on local variability, and we applied some focal statistics able to identify points causing high local variability. For example, in an area where yield is tendentially high, we were able to identify a point where yield was low and identify it as an outlier. The third step was the identification of extreme values by a typical formula that is commonly applied to identify outliers in statistical sense. Also because we rely on the fact that we assume that the distribution of yield is normal across one field. And then we also added the two last steps that are able to harmonize data even if they come from different machineries, as in the study case that we worked on, and also to harmonize data with data at mill. In particular, co-registration was able to harmonize data coming from two different machineries, and post-calibration harmonize yield data collected on field with the yield data at mill. We applied at this step. At this stage, we just applied the procedure on a case study that is actually a realistic worst case, because we selected 4 fields located in a hilly area in the central Italy, in Umbria. And the northern fields, as you can see, there are very low yield values, but the point is that there the yield, the width was lodged. So we had a lot of local variability. The harvester machineries were not so, didn't work very smoothly. The width was partially damaged and so on. And we applied the one methodology on this case, but also on this field, but also on the neighborhood fields that are more, let's say, more normal, that were better. And the algorithm performed quite well in all 4 fields analyzed, because in the more damaged fields, they were able to eliminate all the areas where there were some problems. While in the other field, they seems to eliminate just points where the outliers can be identified empirically. We also showed these results to the farmer, and he agreed that it was quite corresponding to what he expected, even after the reconstruction by interpolation that we made on the figure C, as you can see. To analyze the improvement of the distribution, we also calculate the skewness and kurtosis of the distribution before and after the data cleaning. Here you can see the entity of the increase, and you can also see that before the data cleaning, we had 2 different data sets, because in our fields the width was harvested by 2 different machineries. That also complicates the application of this method. But anyway, the distribution after the data cleaning is tendentially normal, with a kurtosis that is quite near the value, the optimal value, that is 3, and skewness that is just a bit higher than 0. So thank you for your attention, and okay, any question is welcome.
Thank you very much, Sarah, for your presentation. And any questions? Let me check on YouTube. No, later on YouTube. Just is more a curiosity than an actual question. From the end user side, how much are you confident that this application can become an actual application to be exploited by the end user? Are you close to this step, or further research activities are needed?
At the moment, we are carrying on more research activity, especially on testing this procedure, because we just tested it on 4 fields, but it's not enough. At the moment, we are working on 400 hectares in central Italy for 2 years, but the idea is also to test them in other environmental situations, because the results may vary.
Okay. I made this question because, of course, you are representing a small medium enterprise, so it is important to highlight how the collaboration between academia and enterprises can lead to such results. So thank you very much to you and to the other co-authors. And then we can introduce the third presentation scheduled this morning from Grazia Tosi, University of Perugia, GNSS Network RTK for Automatic Guidance in Agriculture, Testing and Performance Evaluation. And the authors presents research on validation and optimization of automatic and semi-automatic guidance systems for agricultural machinery, based, of course, on GNSS network. So, please, Grazia, I leave the floor to you for your presentation. You can share your screen and you can proceed. Thank you very much.
Sorry, one moment. I have to share the correct one. You see, I have always the same problem.
Try to
refresh.
To switch in
presentation mode.
Impostazioni di visualizzazione. Click on the menu.
Yes.
The drop menu. Probably you can switch your screen.
Okay. I don't know why. Can you hear me?
Yes. Yes.
Okay. I closed the presentation. Now I try to share with you. So let's try. Okay.
Okay.
Can you see?
It's okay now. Perfect.
It's okay?
Okay.
Perfect. Okay, yes. Thank you for your presentation. Good morning to everyone. I'm going to show the result of a research concerning the use of automatic and semi-automatic guidance system in agriculture based on NRTK positioning systems provided by GNSS networks. The research was carried out on different test areas located in Umbria, central Italy. The purpose was to test the applicability, the coverage, and the reliability of NRTK approach on agricultural application using RTCM correction stream via entry protocol provided by the regional permanent network called GPS Umbria. You see, okay. The GPS Umbria network, realized in 2005 and updated in the last years, includes 13 GNS permanent stations with short average spacing of about 35 kilometers. All stations now are equipped with geodetic multi-constellation and multi-signal receiver with choke ring antennas. Here you can see a screenshot of the tracking monitoring service of the GPS Umbria network, where it's possible to check the status for all DSP. Before doing the test, it was necessary to develop some operation. The first step has been the identification of the parcel, the acquisition of the maps, and the vectorization through CAD software. Then all the data collected has been loaded on QGIS software for the creation of a shapefile where it's possible to add other metadata information, for example, cultivation sheet with environmental and agronomic parameters. Then we check the NRTK correction acquisition from GNS Umbria network. For the test, TopCon guidance system has been installed on tractors. During the test, a second receiver, this one, yellow, TopCon Legacy, was installed next to the TopCon guidance system to perform an independent control of the results without any interference, and is used as rover for kinematic post-processing with another receiver used as base station. The test has been performed in 2 different locations with tractors of various sizes and types, as you can see from the images, wheeled and tracked, executing different agricultural activities, sowing, fertilizing, and harrowing. We compare 3 driving modes: manual, assisted, and automatic. For the post-processing, we use the TopCon tool software, computing the 3D coordinates of the base station by static connection with 2 permanent stations of the GPS Umbria network. Then we compute the rover trajectories installed on tractors by kinematic post-processing connection to base station. The post-processing trajectories were compared then with the real-time obtained from the onboard TopCon guidance system and used for the next evaluation. To evaluate the efficiency of the supported guidance system, first of all, the trajectories were divided into individual rectilinear strips. Then, for each strip, the transverse displacement of each position with respect to an average straight line was evaluated. A statistical analysis was performed on the transfer displacement, and finally a comparison between the results of the 3 different driving systems, manual, assisted, and automatic, was performed. The figures show some graphs comparing the transfer deviation from the average straight line for different processes and machines. As you can see, with manual system, blue line, there are relevant transfer displacement from the ideal path. The deviation decreased with the assisted driving system, but the most accurate results are provided by the automatic system with the smallest transverse deviation. The statistical parameters referring to the previous analysis are summarized in this table. In relation to manual driving, the root mean square values reduced consistently with automatic guidance, obtaining the small value of 6 centimeters. The worst one for the automatic guidance is only 12 centimeters. The second step was to evaluate the economic benefits. In agriculture, costs are generally proportional to the worked areas. The main parameter to evaluate benefits or losses are gaps and overlaps between adjacent strips and its percentage on total area worked. So, from the footprints of the processed area, it's possible to define the intersection between contiguous strips areas as overlaps, and the difference between supposed total area and actually processed total area for each pair of contiguous strips as gaps. In this table, overlaps and gaps values are summarized for different guidance systems on various test groups. In manual guidance, there are always strong overlaps, 10% and more of the processed area. This is due to the fact that the driver tends to avoid gaps. With guided system, semi-automatic and automatic, overlaps greatly decrease. Instead, gaps are bigger using GNS guided system than manual drive, but always with a small percentage, around 1% or less. Overlaps and gaps are caused by transverse deviation of the tractor from the ideal trajectory. So, to assess their entity, an analysis in terms of area between actual trajectories and the ideal one was performed. The figure on the left shows the transverse deviation for one strip. So, referring to the figure, it's possible to define a parameter, the mean deviation, d star, as the ratio between the total deviation area, also called error area, and the total trajectory length in meters. The lower d star, the better the efficiency of the guidance system. These parameters values for the analyzed strips is shown on the following graphs. On right, it's clear that the automatic guidance is the most advantageous one, leading to obtain mean deviation values of about 5-10 centimeter order. This value allows to evaluate the saving achievable with automatic guidance system, but is referred to a unit width strips 1 meters. And actually, the width can be different depending on the tractor. So, considering a generic width with a length and a length L strips, it's possible to define another parameter, the deviation index, as the percentage of the error area on the total processed area. This graph shows, given a certain d value and the width S of the processed strips, how much is the percentage of cultivated area involved by gaps and overlaps, in order to determine the increase or reduction of cost and times for the process. The deviation index, the lower the better, obviously, gives a measure of the performance of the guidance system in economic terms. Finally, to evaluate the efficiency of the guidance system, the code correction modes were also tested, D, GNSS, and EGNOS. The results are summarized in this figure. It can be noticed that with assisted guidance, the code correction provided good results, but obviously, as expected, phase correction, VRS or CMR, produce better results than code ones and confirm as the most suitable approach for obtaining good results, especially with automatic guidance system. So, the results obtained from this research have highlighted many aspects of the GNS technique application in precision agriculture, and the advantages of this adoption appeared clearly. GNS and RTK technology applied to agricultural equipment brings significant benefits under several points of view. First of all, we have a greater reliability and stability using network correction. Also, the possibility of covering large territory, operating a global reference system. We have a reduction of cost due to the fact that we reduce gaps and overlaps. Also, a reduction of the environmental impact, for example, water conservation and decrease like chemical products. We increase the efficiency. And also we reduce the operator stress. And it's good because we can produce yield maps thanks to the georeferencing for optimizing the agricultural processes. Thank you for your attention.
Thank you very much, Grazia. Any questions? Let me check on YouTube. No? Okay. Grazie. Just a rapid question about the economic aspects related to the cost. Is such approach dependent from the extensions of the fields, or you can apply such approach also to small-sized parcels?
Yes, it's obviously related to the extension of the fields, but we have seen that also with small fields, because in Umbria, obviously, we have small fields, we can reach with these technologies benefits in terms of cost for the companies.
Yes, the cost benefits are compensated by the more efficient plan and path performed by means of the automatic guidance, of course. Yes. Thank you very much. Thank you for your presentation. Okay, the last presentation of this first part of our workshop is from Benedetta Cucca from Tuscia University. The contribution of remote sensing and silvicultural treatments to the assessment of decline in a oak deciduous forest the study case of a protected area in Mediterranean environment. The authors have analyzed an area in oak forest near Rome, and developing a forest health condition modeling tool based on the application of multispectral satellite data. And in this presentation, Benedetta Cucca will show us their activity as a result of this research. So, thank you, Benedetta, for your presence, and I leave the floor to you for your presentation.
Okay, thank you. Good morning, everybody. I'm here to show you this work, the contribution of remote sensing and silvicultural treatments to the assessment of decline in oak deciduous forest. The study case is a protected area in Mediterranean environment. Before to start, I want to mention my professor Canatesi, that is the author, my colleague Matteo Piccino, Carlo Maria Rossi, and the professor Ripa. So, a quick introduction.
Yeah, we can try to do that.
So, sorry? Any problem?
It's okay, it's okay.
It's okay. Sometimes we have some interferences. No, please, without any problem.
So, as I say, a brief introduction about oak decline, that is a complex disorder or syndrome in which several damaging agents interact and bring about a serious decline and recondition. The agents can be abiotic or biotic, and the latter often can be insects and fungi, which are not capable of invading healthy trees, but can be very destructive to weakened oaks. So there are many contributions in scientific literature about this topic, and here you can see some symptoms. For example, the presence of the trees, the foliation, and the detachment of the bark, and so on. So our study area is Castel Porziano, a natural reserve close to the city of Rome. It extended for 6,000 hectares, of which 3,000 hectares are occupied by the oak forest. From the climatic point of view, it's located in the Mediterranean area with a dry period from May to September. As a natural reserve, there is a forest management plan that is in force from 2010 until 2020, from which we have taken the information about cultivation classes. And in this plan has identified the factors limiting of surviving and growth of oak forest. These factors are the absence of renovation, the climate change, the senescence of the forest, and the anthropic pressure. So here, okay, here I've reported some example of forest decline, and you can see clearly the elements of the foliation and the dead branches. So the aim of this research is to develop a tool for environmental risk management in order to identify the best silvicultural treatments to improve the renovation natural process. To achieve this goal, we started with the monitoring of the oak forest through multispectral images from Sentinel-2 and the application of vegetation indices. But given the high heterogeneity of the species present, it was necessary to develop a georeferenced grid with a spatial resolution 100 meters square. And this allowed us to apply the NDVI to detect the health vegetation status of only oak canopy detect. The second aspect concerns silvicultural cuts. In fact, silvicultural models have been developed in order to facilitate a natural regeneration through experimental area. So the creation of the referenced mask was made necessary, as I said, by the high spatial heterogeneity in terms of deciduous oak at the forest unit management scale. there are some example of heterogeneous distribution of oak canopy detected. So the green dot here represents a cell of Sentinel-2 with presence of deciduous oak canopy. So to do this, the referencing dataset was set up using information provided by Castelporziano Forest Management Plan concerning the different height referred to dominant and dominated layer of forest, the leader data, the difference of NDVI to detect evergreen species, and photo interpretation and field data. So here I can show you an example of application of vegetation of NDVI on the Sentinel-2 mask, where all species other than deciduous oak have been excluded. So this is for the difference here. About field data, to analyze the natural review, the natural renovation have been made in 2012. A forest plot of 12 hectares has been strengthened to exclude wildlife, and in 2013 was divided into 3 parts named ABC and subjected to different silvical treatments to promote the forest renovation. One of them was no cut. The cuts were made in these percentages. 17% of dominated layer in the first area, the 19% for the second area, and 0% for the last area. Finally, from 2013 to date, have been placed under mature tree cover a plot area each of 25 meters square, and we monitored for heavily here. So preliminary results show that the outing of wildlife has a positive effect on the development of renovation. With regard to the effect of silvicultural treatments on renovation, it's noted that the number of seedlings present on the different plots show different trend. So you can see here in the first 2 plots, plots A and plots B, thinning has a positive effect on the capacity of regeneration, while in the third, where no cuts were made, the presence of the dominated layer represents a limiting factor. Between the 2 first plots, plots A and B, in which 70 and 19% of the dominated plan were removed, it's evident that the first one has given better results. And the remaining dominated plane has represented an obstacle for the pioneer species, which in the case of the second plot have represented a disturbing element for the renovation. So, in conclusion, the georeference database concerning the canopy of deciduous oaks represents an essential tool for remote sensing from multispectral images, in view of the high heterogeneity of the stump present in Castelporziano. The analysis of multispectral data from Sentinel-2 and Landsat-5 show a state of suffering of the cultivation class deciduous oak trees present in Castelporziano. The exclusion of wildlife carried out in Campo di Rota showed a good capacity in terms of natural renewal in the plot area observed, and the thinning carried out on the forest-dominated plan have in some cases favored the introduction of pioneer species which have multiplied the seedling planted. So, for this reason, it's important to clean up and to accompany the development of the seedling in the first year after planting. Thanks for the attention.
Okay, thank you very much, Benedetta. Any questions?
Okay.
No questions here, neither on YouTube. Okay. Just a question about the future developments of this work. have you planned further collaboration with the Castel Porziano management in order to analyze and to support their ongoing activities?
Yes, of course. We're working in collaboration with Castel Porziano, and of course we take some information and data from the management, the forest management plan. So it's a very important moment to develop this method to monitoring the deciduous forest in these cases.
Okay. Thank you very much. So,
thank you.
Thank you for your presentation. Thank you to you and to the other co-authors of your work, of course. If I check on YouTube, no
yes,
questions.
I also checked on YouTube, but we have no questions.
No questions. Okay.
No.
Okay, Giuseppe, I guess that we can close.
We can go through to the second session, or we wait at 10 o'clock.
Yes, I think that we can wait to 10 o'clock in order to start.
Or anyway, we just give 5 minutes of a stop, and we can. What do you want? Actually, we have all connected on the channel, and if you want, we can proceed. Therefore, we have some additional times, or we will finish before. We are on time, actually. Okay.
No problem for me.
If you want, we can proceed.
Okay.
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 Therefore,
this is.
We have. We can start the second part of our section, Geo4Ag 1, and sorry, with Geo4Ag 2, with 4 presentations. The first one is provided by Benedetta Cucca, evaluating the potential vegetation indices in detecting drought impact using remote sensing data in a Mediterranean pinewood forest. Second one, we will show by Gian Domenico De Luca, unsupervised burn area mapping in a protected natural site, an approach using SARE Sentinel-1 data and the key-mean algorithm. Third one, we will show by Maurizio Pollino, spatio-temporal dynamics of urban and natural areas in a northern littoral zone of Rome, land cover change analysis during the last 30 years, preliminary results. And finally, the presentation fourth is provided by Francesco Santaga, using Sentinel-2 data to guide nitrogen fertilization in Central Italy, comparison between flat low VURT and high VURT rates application in wet. But Francesco Santaga is connected to the session.
Yes, I'm connected.
Okay, nice to meet you, Francesco.
Nice to meet you.
And if you agree, we can proceed with the first presentation that we will show by Benedetta Cucca. Benedetta, are you here, Benedetta?
Yes, I'm here.
Okay, can you share your desktop for your presentation?
Okay. So, okay. Just a moment.
Okay. So, you're on time. Don't worry.
Okay.
So that we decided to start quickly, so we can have more time if we need more minutes. I will remember that each presentation lasts 8 minutes plus 2 minutes for question and answers. So, Benedetta, you are ready to present. You can go if you want.
Okay. Good morning again. I'm here to show you my second work evaluating the potential of vegetation indexes in detecting drought impact using remote sensing data in a Mediterranean pine wood. Also here I want to mention the co-author, Professor Recanatesi and Professor Riva. Quick introduction the cluster that is caused by the interaction of several biotic and abiotic factors, including anthropogenic factors, which lead to gradual deterioration of the forest and the death of trees. So multiple dieback epiphytes in Mediterranean conifer forests subject to long dry spell confirm that pine species
Benedetta, I don't hear you.
Benedetta, maybe you have
A bad connection. Yeah.
Yes. Try to refresh your page.
Benedetta, we cannot hear you. Valentina, how we can proceed?
If you want, we can proceed with the next presentation, and we can wait if Benedetta try to resolve the problem.
Yes.
I think that she has a connection problem.
Yes, I think so. Therefore, Gian Domenico, are you ready to start your presentation? So
yes.
Please try to share your desktop so we can try to proceed with your presentation.
Yes.
Okay, in presentation mode, Gian Domenico, please. So the presentation is anthropomorphized barn area mapping in a protected natural site, an approach using SARS Sentinel-1 data and Kimin algorithm provided by Gian Domenico De Luca et al. Please, Gian Domenico, 8 minutes for you.
Okay, good morning. I'm Gian Domenico De Luca, a PhD student from Agriculture Department of the University of Reggio Calabria. This work was conducted in collaboration with the Institute of Methodologies for Environmental Analysis of National Research Council of Potenza. In the Mediterranean basin, wildfires represent one of the main disturbances which causes economic damage and significant change in landscapes, forests, and environmental ecosystems. For this reason, timely and accurate detection and quantification of burn areas is a necessary step for assessing the damage and addressing the post-fire management. In this context, remote sensing provides reliable tools and techniques for detecting and quantifying the burn areas. The majority of studies has been based on multispectral satellite data. However, these platforms are sensitive to some environmental conditions, such as sunlight, cloud cover, and fire smoke. On the other hand, other kinds of satellite sensors are available. One of these, the synthetic aperture radar, provides an efficient system for discriminating events that cause change in objects on Earth's surface. It is an active system that generates its own impulses and transmits them from its antenna to a target, calculating the time and the amount of return wave or backscatter. The penetration capacity of the impulse in the metal is directly proportional to the wavelength. To detect burn areas, radar technology exploits the variation in backscatter caused by the modification of the destructor and moisture content of the vegetation and of the cover soil.
Several space missions provide satellite constellation operating cell imaging useful for Earth environment monitoring. Copernicus missions by European Space Agency provides free eye spatial and temporal resolution data both from SAR sensor with Sentinel-1 mission and multispectral sensor with Sentinel-2 mission. The Sentinel-1 constellation comprises two polar orbiting satellites performing C-band radar imaging. Sentinel-1 images are available in 4 acquisition modes and 2 product types for level 1. In our case, Grand Range Detector level 1 was used, taken in interferometric wide slot mode that provide the multi-look intensity and amplitude information only. The data were dual polarized. The two polarization available were vertical, and vertical horizontal. So the aim of this work was to investigate the capabilities of our Sentinel-1 sensor for mapping a Barnett forest area. The approach used is based on an unsupervised clustering using the gaming algorithm, and all the processes were performed using open source software and libraries. The study area, located in the central area of Sicily, is a natural reserve. The large part of the woodland was covered by a census of generous eucalyptus and pinus. The event occurred on August 10, 2017, and covered 38.51 square kilometers. The Sentinel-1 temporal series were downloaded using the interactive graphical user interface of Copernicus Open Access App. In total, we acquired 2 Sentinel-1 datasets, the pre-fire time series and the post-fire time series, formed by 11 images for the pre-fire period and 5 images for the post-fire period. In addition, we downloaded 2 Sentinel-2 Level 1C images acquired before and after the fire, respectively, in order to obtain the reference map based on the optical vegetation index. The Sentinel-1 data preprocessing was performed using the Sentinel-1 toolbox implemented in the ESA SNAP software. The same preprocessing procedures were separating applied to each time series dataset, pre- and post-fire, respectively. Looking at the fundamental preprocessing steps for Sentinel-1, the orbit file downloading, the thermal noise removing, the radiometric calibration in gamma and sigma, and the terrain correction with pixel resampling of 10 by 10 meters were carried out. Finally, all images were clipped in a subset area of 3,667 square kilometers. Following in the order to reduce spectrum noise effects, the backscatter time average was calculated separately for the 2-time data series for each calibration knob and for each polarization. Each time average was to an individual layer band, and each of these was used to compute the radar band difference and radar band ratio indices. In turn, for each of these index layer, the GLCM or gray level occurrence matrix mean and variance texture features were computed and appended as new informative layers. Thus, a final dataset consisting of 24 raster layers was generated. All these layers are reported in the present table on the left. The figure on the right shows a subset of the 12 result layer only for the gamma calibration in both polarization. In order to derive a reference map, the Sentinel-2 multispectral data were also processed in ESA SNAP using the Sentinel-2 toolbox. The classic normalized band ratio based on near-infrared and short-infrared band was computed for pre- and post-fire dataset in order to obtain the temporal difference index delta MDR. This index was used as a reference layer since it allows us to identify better the band area's perimeter than other methods. An image clip on the same area of Sentinel-1 data were carried out. Considering of the high number of Sentinel-1 resulted data layers, a principal component analysis was performed to reduce the dimension of the dataset without losing the essential image information, allowing rather to speed up the computation process. The first 5 principal components were chosen as the input layer in the classification process because they reached a cumulative variance very close to 100%. Over this value, as shown in the graph, the principal components lose the importance of the information, becoming redundant. One of the main issues when a clustering algorithm is going to be performed is the preliminary setting of the most suitable number of clusters. To deal with this, the silhouette score was performed. It is based on the separation distance defined by a mean distance between clusters. We calculate the mean silhouette score for different k values in a range from 2 to 20, defined as k-space, using the module already present in the scikit-learn Python library. Looking at the graph, it is evident that for lower value of the k parameter, the silhouette score, therefore the separation of the cluster, is higher. A k value of 3 was finally chosen, giving a better compromise for discrimination of the Shen. An unsupervised classification using the k-mean algorithm was carried out. The k-mean is one of the most popular machine learning algorithms for unsupervised classification, based on cluster analysis. It is also very easy to implement and relatively fast in computation time. The fundamental parameter to set is the number of clusters. We set it to 3 as it resulted from the analysis of the silhouette score. Several small fire events or surface changes that occurred during the period covered by the analyzed time series led to an erroneous assessment of commission errors. To reduce this issue, a post-processing improvement was carried out. First, applying a semi-automatic filter in order to eliminate clusters smaller than 0.1 square kilometers. After excluding from errors clusters that contained a mean value of delta NBR, pixel average greater than or equal to 0.1, that is the Barn-Amber threshold. After this, the remaining clusters were considered as the first level of commission errors related to the general Shen. On the left, the vectorized study Barn area delimited by the proposed approach is presented, superimposed and compared with the reference Barn area derived by delta NBR. On the right, the map shows the areas relating to the correct overlap between the detected Barn area with SAD and the reference area. The omission errors, the commission errors related only to the study area. The total area detected was 38.87 square kilometers, of which the 82.18% was the correct overlap. Looking at the result, the level of overlap is high, and only a relative few small areas appears to be under omission and commission errors.
Giandomenico, okay, you are.
Yes. In conclusion,
okay.
The proposed processing approach proved that Sentinel-1 star data are a viable alternative for rapidly mapping the extent of Barn area, useful when optical data are not available. For future works, in order to test the reliability of this approach, other study areas will have to be considered. Moreover, a significant optimization of the method may be used in more robust machine learning algorithms, would provide for an increase in accuracy. But this will be topics of next investigation. Thanks.
Okay. Thanks to Domenico. Any questions? I'll check on YouTube. We have no questions. And Maurizio, maybe you want to ask something, because actually I am at Coder and I want to bring up to you.
Thank you, Giuseppe. Thank you to Giandomenico for the presentation. It's a very interesting approach. About the future developments, you said that further area will be investigated. It is important to select the areas in a specific way, or you think to find other areas with different conditions, with different land cover type, and so on. There are specifications for this choice, or it is indifferent from your side?
Yes, thanks. It could be interesting to testing this method in a lot of kind of areas. For example, Mediterranean areas, but in forest areas, non-forest areas. But this is relative to the SAR characteristics, because there are a lot of geometric distortion. So, for example, if a plane, if a forest in the mountain, for example, in where the terrain is slope, is more difficult to test the Sentinel-1 data. So an improvement in the method is necessary and correlated to the issues of the area. So,
yeah, of course.
please.
Okay. Thank you, Gian Domenico.
Okay, thank you, Giando. Next presentation is about a spatio-temporal analysis and provided by Maurizio Collino and others. So please, Maurizio, when are you ready to share your desktop?
Oh, okay.
And in the meantime, I show your work entitled Spatio-Temporal Dynamics of Urban Natural Areas in the Northern Littoral Zone of Rome, land cover change analysis during the last 30 years, preliminary results. Is analysis on 30 years, more or less, provided analyzing Landsat family satellite images and with change detection analysis and some indicators provided by this work. So Maurizio, when are you ready? You can
okay,
start your
I'm ready. Thank you for your introduction, Giuseppe. And I will show you this study focused on the littoral zone between Rome and Civitavecchia in the northern part of Lazio region. We have analyzed several Landsat scenes from 1990 to 2019 in order to map and describe the land cover change in this particular specific area of the Lazio region, in which we have detected, as expected, some transformation in the natural and rural areas, but also, of course, a relevant urban growth and expansion related, as you can imagine, to the proximity of the capital city of Rome. The study area is located in this narrow strip coast between the Tyrrhenian Sea and the Tolfa Mountains in the northern part of Lazio, north of Rome. This is an area characterized by medium and small-sized municipalities. The medium-sized is Civitavecchia, the small-sized is Santa Marinella, an intermediate size is represented by Cerveteri and Ladispoli that have increased their population and their artificial surfaces during the last 30 years especially. For this reason, as I said, we analyzed 30 years of Landsat satellite images. We classified using the semi-automatic classification plugin of QGIS 5 Landsat 5 TM scenes and 2 Landsat 8 scenes. With 5 years of interval between 2 consecutive Landsat scenes, if possible. For example, for 2010 and 2015, it isn't possible in order to consider a proper and useful image to be exploited. So we moved our selection to the previous year in both of cases. And at the end of the classification process, we obtained 7 different land cover maps, classifying the urbanized and artificial areas, the woodland, the rural shrubland, the arable lands, and the water bodies in the area within the area of interest. So, by comparing all the 7 different land cover maps produced, we obtained and mapped the land cover changes within the area of interest. So, as you can see in the right side of the slide, you can see the northern part of the study area, comprising the municipality of Civitavecchia and Santa Marinella. And in the left part of the slide, you can see the municipality of Cerveteri and the municipality of Ladispoli. Of course, we have also assessed the amount in hectares of the land cover changes and the transitions between each land cover class to another, in order to have the overall picture of the situation during these last 30 years in the study area. So, at this point, it is possible to make some considerations. First of all, we have observed a decrease of the area covered by artificial surfaces, but this is related in the last part of the time interval considered in the last 10 years is related to the reduction of greenhouses which were largely diffused in this area in the plain of Cerveteri during the 80s and the 90s of the past century. So we also observed an increase of cultivated shrubland areas, especially in the peri-urban areas, and an expansion of the cultivated shrubland areas due to the presence of the aqueduct of Consorzio di Bonifica Litorale Nord realized since 2002. On the contrary, sorry, I moved the bar. On the contrary, we haven't detected any relevant variation over the last 30 years for wooded areas. But of course, this is obviously due to the presence of natural protected areas and also to archaeological protected areas, because nearby Cerveteri there is the Etruscan necropolis of Banditaccia. So this area is protected both from environmental and archaeological point of view. And this has favored the continuity of wooded areas during the last 30 years. Now, focusing on the artificial surfaces, we have detected the typical phenomenon of urban sprawl correlated to the population dynamics observed during the time interval analyzed. In particular, municipalities such as Cerveteri and Ladispoli have considerably increased their population, and this population increase, of course, caused an urban expansion. And of course, the driving factor was the presence of Rome, which have conditioned the expansion of these areas into different ways, as we can see in the next slide. First of all, we have in the 70 and 80 or 80s of the past century, we have an increase of the urban areas related to the floating population during the summer vacations. So these are second houses linked to the seasonal tourism pressure, and are mainly located along the coast. So we have the typical littoralization process. But from the late 90s, the summer vacations changed in our vision as typical habits of people living in Rome. And then we have the phenomenon related to the commuters, which, benefiting of the transportation connection, the railway connection improved since the 2000. The motorway and the other road connection. So we have many people that started to rent the dwellings located in this area and exploiting the transportation network to move every day to Rome to work. So, in conclusion, we have analyzed this area that in the last 30 years has largely increased the population and has shown an urban sprawling expansion, especially in the coastal strip between the sea and the hill. And the preliminary results allowed to understand that the natural and rural land transformation are mainly related to the proximity of Rome City. So, starting from these results, we will move to the future developments of our study. And in particular, we will be focused to the analysis of mixed areas, especially in the peri-urban zone, by exploiting remote sensing data with higher spatial and spectral resolutions. And we will integrate also other type of census data, not only population, but also agriculture. And in addition, we are planning to exploit other approaches, more effective, and other indicators in order to further analyze and study this area. So this is all from my side. Thank you for your attention.
Thank you very much, Maurizio, also to be on time and for your interesting work. Any questions from the from the audience? No, also on YouTube we have not questions. So Maurizio, it's up to me to make a question, and my question is about your future research, your future development about, for example, landscape fragmentation. How you can think this phenomenon can be studied, can be deeply analyzed to enforce your findings that you presented here. For example, you also stated that some geospatial analysis like LISA indicators could be integrated in a future development, for example. Just 2 words about that.
Yes, thank you for your question. Yes, as you say, it is important now to go in deep in our analysis. Of course, at this stage, we reached a sort of overall picture of the situation during the last 30 years. But now it is important to more effectively and accurately analyze for example, the peri-urban areas. For this reason, we will apply some approaches based on the analysis of landscape metrics in order to better analyze the fragmentation, because it is an aspect that arose from this first analysis, the fragmentation. And also other approaches such as LISA can help us to better understand some dynamics in specific areas. Probably we will focus mainly our attention in the southern part of the area, because is that with more fragmentation and more interesting dynamics to be analyzed and understood, of course. So in the next approach, this is our plan to be followed.
Okay, very interesting. Therefore, Valentina, we can proceed with Francesco Santaga, or we have also Benedetta Cucca with us.
If you want, we can try if Benedetta is okay now.
Okay, Benedetta,
Yes,
are you here?
I'm here. Yes,
Okay.
yes, I'm here.
Okay,
I'm
no,
sorry
no
for
worries.
the
Try
problem.
to back on your presentation. Please share your desktop, and you can proceed directly to your work.
Yeah, I hope everything is
Yes.
well. So,
Okay, 8 minutes for you.
Benedetta, I'm sorry. Turn on your microphone.
okay, okay. You can hear me?
Okay. Yes.
Okay.
Yeah, now
Yes.
here.
Yes, sorry. You can see my my presentation now. Can you see my presentation?
Yes. Yes.
Okay, I'm sorry. I hope finally. So I'm here to show you my work evaluating the potential of vegetation indexes in detecting drought impact using remote sensing data in a Mediterranean pine wood. I want to mention the co-author, Professor Cantesi and Professor Ripa. So, a brief introduction. The decline of forests is caused by the interaction of several biotic and abiotic factors, including anthropogenic factors, which lead to gradual deterioration of the forest and the death of trees. Multiple dieback episodes in Mediterranean conifer forests subject to long dry spell confirm that pine species are particularly prone to drought-induced growth decline, needle loss, or defoliation and mortality. There are many contributions in the scientific literature about this topic, and also we already work on the pine forest in Castel Porziano during the Tomicus infestation in 2016. So our study area is the natural reserve of Castel Porziano, is close to Rome. It extended for 6,000 hectares, and the pine wood it extended for 9,000 hectares. For the point of view of climate, we are in the Mediterranean region with a dry period from May to September. So the main cases of virus dieback are climate change, the groundwater lowering, the pest infestation by Tomicus destruens, and the anthropic pressure. So, before to continue, a brief introduction on the concept of drought. There are three definitions of this drought phenomenon: meteorological, agricultural, and hydrological. Of course, in this work, will deal with the agricultural drought, which affects the plant component of the ecosystem. So the aim of this research is to evaluate the main vegetation indices proposed in literature to monitor the effects of drought in Mediterranean pine wood. To achieve this goal, we started with the monitoring of the pine wood through multispectral images from Sentinel-2 and the application of vegetation indices. So here you can see the band we used to do this monitoring, band 4, 8, 8A, 11, and 12, referring to the period August. To better understand the capacity of these indices, we do a reclassification of pine forest according to the dendrometric criteria into three volume classes and 3 age classes. So we are, as I said, we apply the vegetation index that are quantitative relationship based on the typical absorption and reflection bands of vegetation. The resulting value reflects the contribution of vegetation as a function of the spectral response, while minimizing the contribution of the other factors such as soil or light condition. We use the NDVI index that is widely used to monitoring health vegetation condition, the NDII, normalized difference infrared index, and the normalized multiband drought index. So, about the results in the observing period, we apply the vegetation index to the entire pine wood. And to emphasize the results, we use the year 2015 as a reference here. And the indices show that the best effectiveness in terms of detecting diachronic condition are NDVI and NDII. In fact, NMDI index show a lower variability. So, for this reason, we applied these two indices according to the classification made previously, referred to volume and age classes of the pine wood to better investigate their capability. The graphs show better results for the intermediate classes, and this depends on two main factors. In fact, in the younger pine woods, since they have a more expanded canopy, the cell is not able to efficiently discriminate the foliage from the ground. On the contrary, from the larger classes, the dense cover does not allow to distinguish healthy individuals from the suffering ones. So, in conclusion, at the scale of the whole pine wood, it's evident that NDVI and NDII index better differentiates the change in vegetative health status for the observed period. And NDI index show a lower variability of the data for all the years observed. In both cases, the best differentiation of data is found in the intermediate classes. Of course, these preliminary results need further studies and field investigation to better understand the potential and the limiting factor of these indices. So thanks for the attention.
Okay, thank you, Benedetta, for your presentation and also to be on time. And
okay,
maybe we have some questions on YouTube. We have no questions. There are some questions from the audience. No. So I can ask something. And what about the normalized drought index? How it was not useful in your research, in your opinion? Just curiosity.
So we think that we don't the NMDI index show a lower variability in the different year that we detect. So we think that it's not good to apply on the pine wood forest, but also. But this is just a preliminary study, so we want to improve this method and maybe apply this different index not only on the pine wood forest but also in the other cultivation classes. For instance, the oak deciduous forest or the other one. So. That's my opinion.
Okay. Okay. Thank you, Benedetta, for your answer. Okay. Therefore, we have the last presentation from Francesco Santaga.
Yes. Good morning, everyone.
Good morning. Pronunciation is correct, Santaga? or I was wrong?
Santaga is correct.
Okay, thank you. Your work is entitled Using Sentinel-2 Data to Guide the Nitrogen Fertilization Central Italy, Comparison between Flat Low VRT and High VRT Rates Application in Wet. So we conclude our session with the third work on precision agriculture, actually. Therefore, Francesco, you have 8 minutes to show your work.
Okay, try to show my screen.
Yeah.
Okay, yes. Okay. So can you see the presentation, yes?
Yeah, it's fine.
Okay, perfect. Good morning, I'm Francesco Santaga, and the following study talk about using Sentinel-2 data to guide nitrogen fertilization in central Italy. Comparison between flat, low VRT and high VRT rates application in wheat. First, really quick introduction about precision fertilization. N is the main nutrient in the vast majority of the crops, like also wheat, and increasing and rate increase yield, but also increase the risk of leaching that cause several environment impact in near surface and deep water. In this regard, new technology like remote sensing, GIS system, and variable rate technology can help to modify and optimize N distribution by a map-based precision fertilization approach. This improving economical and environmental sustainability. In this work, the study is carried out in a rain-fed winter wheat over 2 fields and 2 years. The aim was comparing 2 different VRT and fertilization treatments based on Sentinel-2 and above all easy applicable approaches versus a standard flat rate. The comparison was made in terms of NDVI seasonal trend, grain yield, and protein content. The comparison about 3 theses was applied only in the second fertilization. The first treatment is a flat N, and it was a standard rate derived by N balance approach. The second is var N low, and was a variable rate based on Sentinel-2 and DVI, where the maximum rate is equal to the standard. The last, var N high, was a variable rate based on Sentinel-2 and DVI, where the average rate is equal to the standard. For both variable approaches, an inverse linear relationship between NDVI and the VRT doses was adopted on the assumption that NDVI before the second fertilization are directly related to the nutritional status and nutritional status of the crop. So to avoid unknown special actors noise, the experimental R was divided into experimental units, into plots, where the 3 treatments were laid down according to a randomized design. NDY was calculated for from a Sentinel-2 image collected a few days before second fertilization, and these images was used to calculate the prescription maps with a linear relationship imposed between the average NDY value calculated for all experimental units and the fertilized N rate. The relationship was imposed by making that 5th percentile of the NDY value corresponded to maximum for the N rate, and the 95th percentile of the NDY value corresponded to the minimum N rate. And for field 1, harvest was carried using a combine equipped with TopCon heel tracks system. And after that, average yield value were calculated for all experimental units. And this averaging procedure should attenuate the possible inaccuracy generated by yield track system. For field 2, harvest was performed separately, collecting and weighting the yield by each experimental unit. This is a time-consuming procedure, but allows us to obtain very accurate yield data. And results show that for both fields, the 3 treatments did not differ significantly for total yield, and no relationships was found between N rate and yield. Just a slight difference in protein between treatments, but also if it's statistically significant, is probably not agronomical significant, because just 0.7 point of difference is yes, a little difference. Finally, the N rate increase did not translate in a nitrogen use efficiency increase. After that, all relevant Sentinel-2 images with no cloud were collected for the 2 study area to analyze the trend of NDY, seasonal NDY in the 3 treatments. And no relevant difference between fertilization treatment was found in both fields, just a little bit in the second field. Okay, in conclusion, the results show that VRT approaches with a lower overall N rate may be more efficient, because give the same green yield and a comparable quality, but with a lower N input. VAR and low also could determine a lower protein grain content, so economic trade-off between lower N cost and reduced yield value should be determined by farmer, analyze the local price. And moreover, the N rate reduction result environmentally very relevant, since it could reduce water pollution. That is still critical issue in Umbria, Italy, and in general in all over the world. Thank you for your attention.
Thank you, Francesco, for your interesting presentation. Some question from the audience. I also check on YouTube. We have not questions.
Okay.
For now. And I have just a question for you. And what do you think about the use of also UAV imagery coupled with satellite to better understand the behavior of nitrogen content and yield crops, for example?
Okay, thank you for the question. Yes, but probably the UV images are more efficient also for the cost, the major cost compared to Sentinel-2 data that are free, are more efficient for a culture like vineyard or other, where the more spatial resolution is useful, because more noise are determined from other factor. I think in width or generally in how do you say props? Yeah, like width or how do you say a big resolution like Sentinel-2 is okay. It's enough for understand the gradient in the field. Maybe for all the sorry, for all the culture that cover all the field, Sentinel data, satellite data probably is enough. For the crops where the field is not covered like mice or vineyard, probably UAV are nice, are good.
Okay, thank you for your answer. Therefore, we just finished our session, and actually we received very interesting papers, and we have also to try to evaluate to give our contribution to the best paper awards with Maurizio, and actually we are very satisfied for your contribution and moreover for your presentation quality, because we received very interesting and arising questions to our field of work. Maurizio, would you add something at the end of our session?
Maurizio,
maybe you have to turn on your microphone, Maurizio, please.
Oh, sorry. It's a typical issue. I guess that Francesco, you have already the screen in sharing mode.
Yeah.
Because I see my webcam into the sharing.
Can you share your desktop, Maurizio, maybe?
Oh, probably if Francesco.
Okay.
Try to disconnect, Francesco.
Okay, try to disconnect.
Okay, thank you.
Okay, bye, thank you.
Thank you, Francesco. Okay, no, so I would like to thank you the authors for their contributions, which make very interesting our workshop, and of course also thank you for your presentations. And I think that for this, which is the first edition of our Geo4Agr workshop, it is a very good starting point for this workshop, because we started with 8 papers presented and published, and 8 presentations during these two sessions carried out this morning. So thank you again to all the authors. And
sorry, maybe we have to remind that in our session we are thinking about at least a special issue, and maybe if our presenters are interested, we can send them an email to explain the special issue project, and I think in the next weeks we can manage this.
Yes, thank you for your information, Giuseppe, because it's very important to consider that the future works and the future developments. This is the screen. Probably. Benedetta, probably is your screen that is still shared.
Oh, sorry. Oh my God, sorry.
Okay, okay.
Okay.
Yes.
Yes, it's okay now.
Okay. Sorry.
we solved this mystery. And yes, I echoing the information provided by Giuseppe, I will also invite you to consider these future special issue related to this workshop, in which you can improve the current version of your papers, and in which you can take into account of the future developments that you have presented during these two sessions. So thank you again to all the authors. Thank you again to Giuseppe, and once again a special thoughts to Marco and his family.
Okay. And also from my side, thank you again to all the authors, and maybe and hoping we will see in the next in the ICCSA conference. So we were perfectly on time to left the room to other sections. So Valentina, it's up to you to guide the closing of our session. Thank you in advance.
Thank you, everyone. And we have many times in order to start the other section. So if you want, we can have a little break now.
Okay.
Thank you,
Very
Valentina.
welcome, Valentina. So we will see as you as okay.
Hoping to see you next year physically to ICCSA 2021.
Bye
bye, everybody.
Bye.
Bye.
Bye bye.
Okay, bye.
Good morning.
Good morning.
Everyone.
My name is Giuseppe Sansonetti.
My name is Valentina Santarsiero, and I am the GT assistant for this section.
Oh, thank you very much.
Thank you very much, Valentina.
Okay.
I think we are going to start in a few minutes.
Yeah, if you want, we can wait a few minutes, and at 11 o'clock we can start if you want.
Okay, just one question. Can we collapse the three subsections into just one longer session? Because we have female 1, female 2, and female 3. And my colleagues, Paola Pepinunno and Pasquale Lopes, which are the chairs for female 2 and female 3, are busy. So
okay, no
we'll have
worries.
a unique chair, me, unfortunately. And so we can collapse in a unique longer section, I suppose.
Okay.
Okay. And one paper has been retired, but is still erroneously present in the list. But I think this is not an issue at all. We can skip this paper when it is the
At
moment.
the end of the section.
Yes.
If you want this paper, this presentation, maybe we'll present at the end.
Okay. And
just a few recommendation for each paper of this section. I remember you to compile the evaluation
to fill the form for choosing the best paper award.
Okay. Yes.
Thank you. Okay, we are going to start into 5 minutes. Good morning to everybody.
Good morning.
Good morning.
Good morning.
Okay, good morning to everybody.
Good morning.
Good morning.
Start with Frontiers in Machine Learning 2020, a specialized session in ICCSA 2020 conference. A special session devoted to machine learning and its recent developments. So we have 8 papers to present, and we have 8 minutes for presentation plus 2 minutes for discussing. So I would kindly request the presenters to respect this time. The first paper in our list is from Imane Ciliui, Ibtissam Abnane, and Ali Idri, a paper entitled Comparing Statistical and Machine Learning Imputation Techniques in Breast Cancer Classification. A very interesting and hot topic. And who is here to present the paper?
I'm here immensely. Hello, everyone.
The audio was not good. I was not able to understand.
Okay, hello. I'm Ashley Wee, and I'm going to be presenting this paper.
Okay. Please, so let's go on. Good morning, Ms. Chliui. And now it's your turn to present the paper. Please. The image is frozen. Okay.
Hello, can you hear me now?
Yes, I can see you. I can see you and I can hear now.
I'm sorry for... Yeah, I'm sorry.
Don't worry about it. So, if you can share your screen and start with your slide.
Okay. One moment, please.
On the left side down, share screen.
Yeah.
Okay. No.
Okay, it's okay now?
Yes. Okay.
Okay, thank you. Hello, everyone. I hope you are all doing good during these challenging times.
Thank you.
Before I start my presentation, I would like to introduce myself. My name is Iman Shliwi, PhD student at the University Mohammed V in Rabat. And my presentation is entitled Comparing Statistical and Machine Learning Imputation Techniques in Breast Cancer Classification. This presentation will be presented according to this outline. As you know, missing data is a major problem when applying machine learning techniques, including classification, since it affects severely their performance, especially when dealing with medical datasets, which is our case, dealing with breast cancer classification. According to a conducted review, a minority of papers discussed the use of missing data techniques for breast cancer classification. And to the best of our knowledge, there is no study evaluating the use of C4 vector regression for breast cancer classification. Moreover, there is no existing experimental design using several evaluation metrics along with significance tests. Based on these motivations, we intended to analyze and discuss the influence of two machine learning techniques, including k-nearest neighbor and supervector regression imputation, and two statistical techniques, including expectation maximization and mean imputation. Thereafter, we briefly present the four imputation techniques used. We start with the statistical ones. Mean imputation considers as the simplest method to deal with missing data, widely used as an alternative of deletion. It consists of replacing the missing data with the mean of all observed cases. We have also expectation maximization, which considered more as a sophisticated method. It consists of two steps. The expectation step, which uses an initial estimate parameter and conditions it upon the observed variables. Then comes the maximization step, which provides a new estimation of the parameter using maximum likelihood. And this process is iterated until convergence. For the machine learning techniques used, we have k-nearest neighbor, considered as the most used imputer, a machine learning imputer. It's based on K-NN algorithm. It consists of imputing the missing value considering the k closest instances according to a given distance metric. And here is the process followed for K-NN imputation. For supervector regression, considered as the regression model of supervector machine, it consists of training the model using the complete dataset and predict the missing value from the incomplete dataset, which will complete the imputation process. For classification, we used 5 classifiers: decision tree C4.5, a supervised learning classification algorithm; a supervector machine, a group of supervised learning methods used to model data not linearly separable; multilayer perceptron, a type of artificial neural network that can represent complex input-output relationships; case-based reasoning, a method of lazy learning known as a non-parametric method; and random forest, which is a generic principle of randomized ensembles of decision trees. Experiments of this study were conducted using 2 breast cancer datasets collected from the Wisconsin repository. The Wisconsin breast cancer original that contains 699 instances and 10 numerical attributes, and the Wisconsin breast cancer prognosis contains 198 instances and 35 numerical attributes. Our experimental design consists mainly of 4 phases, and all the steps were implemented using Weka Java API code. The first one is data removal. To begin, we had to discard the already existing missing data so we can artificially generate them, and then we choose 18% of missing data randomly. At the end of this step, we obtain 2 incomplete datasets. Then comes the complete dataset generation step. During this phase, we applied the 4 imputation techniques detailed previously: mean and expectation maximization. And for when using machine learning imputation techniques, we applied the grid search to vary the parameters. We'll show later a table including all information related to the grid search. At the end of this step, we obtained 276 complete datasets. For step 3, the classifier generation, we implemented the 5 classifiers using as well grid search to vary the parameters, along with 10-fold cross-validation to divide the dataset into training and testing sets. At the end of the step, we obtained 1,380 classification experiments. This table shows the different ranges used for each technique, whether it was for imputation or classification. I should mention here that the optimal configuration for imputation techniques were based on the results of the classifiers used. Here comes the evaluation step. We use 3 different evaluation metrics: the balanced accuracy rate, the kappa value, and the area under the ROC curve. Using different metrics can yield. For this purpose, we used 2 significance tests: Scott-Knott, a clustering method based on the balanced accuracy rate, and then we took the best cluster and applied board account method based on the 3 metrics. After describing the techniques, the data.
The connection is lost. I am afraid that connection is lost. Can you hear me? Yes, connection is lost, unfortunately. Let's wait until I see a noise, a disturbing noise. Okay. Miss Liu is still is here again.
I'm still here. Yeah, you were not listening to me?
No, we don't see the slides. I can see you, but I can see the slides. So I think you should.
Okay, I'm sorry. Wait a moment.
Because the connection was lost for some time, and I think okay, perfect.
Okay, it is good now. But can you tell me when I stopped so I can repeat again?
No.
It's okay. I'm fine.
Don't worry about it. It's good. We are in time.
Okay, I'm so sorry. Okay, I'm so sorry. While based on accuracy on the area under curve, the results were different for each imputation technique. For example, for decision tree, the decision tree mean imputation was the best. For CBR, expectation maximization was the best. For supervector machine, SVR was the best, while for random forest, all results were equal. As you noticed, the results were different based on each evaluation metric, which explained the need of the significance test. Here is the plot of Scott Knott. It shows two different clusters. The best cluster is the one composed of machine learning imputation techniques. Next, we applied the board account method based on 3 evaluation metrics to rank the machine learning techniques. And from the table, it can be seen that SVR obtained the highest number of votes. To conclude, machine learning imputation techniques achieved a better improvement for classifiers' performance compared to statistical ones, and SVR proved to be the best so far. For future work, we intend to carry out more empirical evaluation to investigate other imputation techniques, such as ensembles, either homogeneous or heterogeneous, based on other single imputers. And since the present study only deals with numerical attributes, it would be of great interest to deal with missing categorical data. Thank you. My presentation comes to an end. Thank you for your attention. And I'm sorry for the network. I'm really sorry.
Don't worry about it, and thank you for your interesting presentation. Any question? Any question about the... I have a question. What is your feeling, your opinion about the real applicability of these machine learning techniques in a real clinical context? Personalized medicine is a hot topic today. What do you think about the real applicability of machine learning techniques in screening and diagnosis of cancer?
I think it will be a great interest to start using machine learning techniques in real clinical data. It helps a lot with dealing with huge data sets, but it's not going to give the right answers. We always need the doctors and the opinion of practitioners, and we need to collaborate with them so we can move forward.
I absolutely agree with you. Thank you for your interesting data and presentation.
Thank you.
Thank you. The next paper is from Gianni Fenu, Hicham Laffouli, and Mirko Marras from University of Cagliari, a paper entitled Exploring Algorithmic Fairness in Deep Speaker Verification. Who is here to present the paper?
Can you hear me?
Yes, I can hear you. Mirko?
Okay.
Mirko, are you here?
Yeah, I'm here.
Good morning, Mirko.
Good morning.
The screen is all for you. Thank you very much.
Share my screen.
Sorry, Mirko, your audio is not perfect.
Okay. Let me know if you can see my screen.
Yes, we can see your screen, but we cannot hear you perfectly. Your voice is somewhat is hidden sometimes.
It's a real problem. I know. Maybe I can ask you all the audience to stop the webcam so that we can easily manage the connection.
Okay, Mirko. Yes, stop and reconnect. Yes, no problem.
Now, now. Can you hear?
No, we can. No, yes, we see the screen.
Okay.
We see the screen, but we cannot hear
Massimo,
you.
can you hear? Okay, can you?
No.
Okay, I can try another. I can try again. Okay.
Okay.
Now, can you hear me? Can you see my screen?
Yes. No, I cannot see your screen now. No, the screen does not switch to your presentation.
Let.
No, the connection is lost.
Okay.
Okay.
Okay. Now, can you see my presentation? Massimo, can you hear me?
Yes, I can hear you, but I cannot see your presentation.
Yeah. One moment. Okay.
Prego. Okay, perfect. Right. I can hear you, and we can all see your presentation now.
Okay. Now.
Thank you. Well.
Okay, I can start. Great. Sorry for the promise. Okay. Good morning, everyone. I'm Mirko Marras from University of Cagliari, and today I will show you our work on algorithmic fairness in deep speaker verification. As you know, more and more systems and platforms are requiring to profile people based on behavioral and physical characteristics. And among all the biometrics that can reach this goal, voices are one of the most prominent. And you can see here different applications, and also the market is really growing at a very high rate on voice biometrics. Specifically, to automated system the ability to recognize people based on their voice, we need that this system can be able to map a unique identity to the attributes to the data that is collected by the human voices. In this work, we specifically focused on speaker verification that requires to confirm or refute the identity of a user based on the probe on the voice probe that is fed by the user into the system, so that we can say, yes, this is the user that can access to the system or not. During the years, speaker verification has reached very high accuracy thanks to deep neural networks. Basically, different neural networks are trained by giving them spectrograms extracted from audio waveform, and then from these retraining networks, we extracted the features that are used then for performing the speaker verification task. As you know, so we are reaching very high accuracy with these models, but there are other perspectives that are required to be considered. For example, the fairness perspective. As you know, that there are different laws that go against individual discrimination. So we need to be sure that these models are both accurate but also fair again over the demographic groups that are considered in these systems. So our work was tailored to analyze the fairness perspective of different speaker verification models, so that we can say whether these models are both accurate and also fair against across demographic groups. Specifically, we considered different demographic groups based on the language, the gender, and the age of the users, and we have seen how the error rates of these systems vary based on the demographic groups to assess whether these systems are fair or unfair. This is just a quick recap of our methodology. Basically, we have on the top a data processing pipeline based on the downloading utterances from the Common Voice dataset. It is one of the most one of the largest dataset in this field. We clean and convert the data to easily manage them by the data in the process, and we organized all the data of utterances given by speaker in a hierarchical way, so that we can easily share our data for reproducibility studies. Together with the data, we also prepare different protocols for testing the models based on different demographic groups, and specifically we have prepared different train and test split, and all these kind of assets are prepared in the go through the first voice dataset. That is the dataset that we propose with this work. Then part of the data is used for training our models, and the rest of the data is used for testing our models and assess the unfairness of the considered models. Specifically, we have used so we proposed in this paper a first voice dataset that includes over 1 million utterances given by more than 12,000 users, and we group them based on the language of these utterances, specifically English, Spanish, German, and French. Then from each utterance, from each audio waveform, we extract this spectrogram that are the input that we will give to the models. The model that we have used is the Thin ResNet model that is considered the state-of-the-art model for speaker verification nowadays. So this is to be aligned with the state-of-the-art. We focus in this paper on the unfairness of the Thin ResNet model. Specifically, to avoid to give a different balance to the demographic users, demographic groups in the training, we have balanced the training dataset based on the representation of the different demographic groups. We have considered female users, male users, and based on the age, we have split users in users younger than 40 years old and users older than 40 years old. And these 4 demographic groups are balanced in the training data. And the demographic groups are also balanced in the testing data. Then we have conducted a series of experiments to assess whether these models are unfair against the demographic groups we have considered. And you can see here that the equal error rates that are achieved by the models we have trained on the different demographic groups. I can remember that the equal error rate is the point where the false acceptance rate and the false rejection rate is the same, and the lower the better. You can see that based on the language and based on the different demographic group on the left, you have very different performance. And so we are uncovering the need of a fairer speaker verification, because you can see that in the model, the performance are quite good based on the overall accuracy. But if you consider the differences based on the group, there are huge differences that need to be limited. Then we have also considered the false acceptance rate and the false rejection rate for different demographic groups, so that we can also say whether these differences are related to less usability of the system or less security of the system. And for example, on the left, you can see here that for the female users, we have higher false acceptance rate that results in less security of the system for this group for female users. While for the males, we can see that there are more false rejections. So this leads to higher, to less usability for males. So based on the demographic use, we have different drawbacks: less security for females and less usability for males. And the same considerations can be also done for the age-based groups. Then we have also analyzed the number of errors that are considered by the different demographic groups, and we can see that the errors are quite uniformly distributed based on the group. So no further differences are found here. And lastly, we have also considered we have also mapped the feature and vectors to a two-dimensional space to see where the feature vectors are mapped, and we can see that the models map very close the features based on the demographic groups, and for certain groups the features are more concentrated in certain points, and this implies that, for example, maybe the model learn better to recognize users based on the certain demographic groups where the concentration of the features vector is higher, and less and can recognize less the other groups. So to recap,
1 minute, Mirko. Excuse me.
No worry. I'm in the conclusion. I'm concluding. So basically, in this paper, we propose a benchmark result to evaluate speaker verification model from a fairness perspective to assess whether there are biases that can discriminate certain demographic groups than others. And we have seen that we have uncovered that there are, despite the high accuracy of the models, there are very high differences between the models. So this, with our study, we are urging to promote fairer speaker verification models and to find countermeasures to these biases that we have uncovered. And this is what this is our plan to do this in the next steps. So, thanks for your time, and sorry for the connection problem.
Thank you, Mirko, for your very interesting presentation. Any question? I have two considerations about your paper. The first, it seems to me that the issue of adversarial learning is a very important one. And the second is the error rates seem to be very low. Is this technology ready for real application?
Okay, so basically, thanks for your question. Yeah, basically, considering the latter point, we can say that the models are achieving really low error rates. So they can be somehow ready to be applied in the real world if we consider the overall accuracy. But if we consider the differences that we have uncovered here among demographic groups, we can say that based on the demographic group where these models are applied, we can have different implications. For example, if here in this slide we have uncovered that for German and female younger German users, we have very high equal error rate. Maybe for that demographic group, this model is not ready. So we need, before going in the real world, we need to be both accurate and also fair among the different demographic groups. And this is, as I said, one of the next steps for our work. And for doing this, we are considering different variants of different mitigation strategies. Basically, we are considering to regularize the training process so that during the training of the model, we aim to both be accurate in the classification of the speakers, but also to reduce and to limit the differences in performance among the different users, among the different groups. And maybe by doing this during the training, we can also reach fairer results, fairer and accurate results in the testing part.
Thank you very much, Mirko, for your interesting presentation. Any other question? Okay, thank you very much. Let's go with next paper. A group from Polytechnic, University of Bari and University of Bari Aldo Moro Dario Esposito, Marco Polignano, Pierpaolo Basile, Marco De Gemis, Davide Primiceri, Stefano Lisi, Mauro Casaburi, Giorgio Basile, Matteo Mennitti, Valentina Carella e Vito Manzari, presenting a paper entitled Decision, Data-Driven Customer Service Innovation. Who is here to present the paper?
Hi Massimo. The problem is that Dario had some problems, some unexpected problem. So I will try to present the paper.
It's a pleasure to see you.
Yeah, I was trying to share the screen with Firefox, but
yes, on the left, on the share screen left.
Yeah, yes. The problem is that Firefox cannot allow permanent access to your screen, so probably I need to change browser. So please
maybe.
give me a second.
No problem, Marco.
Okay, I'm changing it. Again. So
okay, I see you again and I hear you again.
Okay, so okay, sure. Okay, you can see the screen.
Perfect. I can see your presentation.
Perfect. That's right. Okay, so hello everybody. I'm Marco Polignano from the University of Bari, and I'm here to try to describe this project Decision. And it is a project that we made in collaboration with the Polytechnic of Bari, but also some other companies that are very active on the our location in our region, Puglia, in Italy. So what is the goal of the project, and consequently of the paper, is to design and to try to define an innovative framework that is able, from one side, to understand what is the need of a user that is trying to use the platform, and to the other side, to try to retrieve from a data set of services what could be the service more that better fit the need of the user. So we are trying to face the problem of information seeking support systems, and consequently we try to define a framework that from one side is able to understand the natural language, from the other side to make queries on a semantic dataset. So what is the difference between Decision and other classic chatbot, we can say? The difference is that a classic chatbot need the structure of the dialogue that the user will have with the chatbot. And moreover, every interaction need to be designed, implemented, and so on. Otherwise, in Decision, we don't have this, we can say, this first step, but the only thing that we need to do is to plug our service inside the knowledge base, and then the chatbot automatically, with a generic interface, will be able to chat with the user, but also to retrieve the parameters that we need for querying the dataset and querying the specific service. So this is the general architecture of our framework. As I said, we have a front end on the left side with some strategies of natural language processing. Then we have a translator in the middle that is able to do this map between the natural language and the services. And finally, we have all the services provided to the framework that could be very heterogeneous, because we have RESTful services, so we can have geo services and so on. We can have what we want here. The only thing is that we need to semantically annotate the service. So we need to annotate the input of the services, what is the goal of this service, and what is the output. And this is the big picture of the architecture of, and more in particular of the flow of the information. From one side, we have the external services that are REST services. These services properly annotated have been indexed using a standard that is HOWL-S, and then we stored this information inside our KB, our knowledge base, that is implemented with the Neo4j. From the other side, we have the user interface that is talking automatically with an orchestrator, so a module that is able to retrieve the information, the query written by the user. Then it is passed to the translator that is doing the match between what is written by the user and what the description, semantic description that we have in KB for doing the queries. So, as I said, we used inside our indexer a standard for the annotation of the services. So this standard is HOWL-S. HOWL-S is an ontology schema that allows us to annotate every part of the services. So it is a standard written specifically for services. And moreover, we have also another standard that is a Swagger, that is able to do more or less the same thing, but with a more innovative and recent interface. Then we, as I said, we do this step, we index everything inside our KB, and consequently, all the information that we store could be queried. I want to provide you a very quick example. For example, the user can write inside the chat box, find please the places to enjoy in London. This query is automatically translated by our system, and we are going inside our index, implemented, as I said, into Neo4j, and we are going to looking for the description of the service that fit more the user query. How we do this? We are using here word embeddings in order to encode such description and the user query in order to be able to compute similarity metric, a similarity metric, in particular the cosine similarity. Then we implemented all these modules, so the framework is working now correctly and it is correctly implemented. And then we decided to evaluate if the framework is working good or not. Then we used 64 queries in English and in Italian, like this one. And we use as metrics mean average precision and mean reciprocal rank, that are two metrics very common in information retrieval and recommender systems. Then what we can observe is that the results are very encouraging, because our translator is able to have a mean average precision of 0.89 and mean reciprocal rank of 0.91 on English, but our results are comparable also in Italian language. And that means that the whole framework is working good, it's working properly, and it can work also with different languages without any problem. And we compare it with a standard tool for information retrieval, that is Lucene, and as we can see, the performances are more lower. So as conclusion, I want to say that this framework has been promoted by the Regione Puglia, and the project has been completely implemented, and now it is in use by some users inside of companies that collaborate with us. And this framework has tried to put together, from one side, the queries of the user, the needs of the user written and in natural language, and to the other side, the structured part, we can say, of the services that could somehow answer to the information need of the user. That's all, and thank you for the attention.
Thank you, Marco, for your presentation. A very complex engine.
Yeah.
Any question? I can see my face twice. No, just yes. I have a question for you, Marco. What is the final objective? But because I can understand that the actual version of your engine is a prototype.
Yeah.
But what is the final objective of your research? When your engine will be, all functionality will be implemented, what is your final objective?
This prototype is currently used already in the Acquedotto Pugliese. That is a very big company for water in Apulia. And the final goal is to be an intermediate, we can say, a tool for allowing the client, the users, to find information about
in a completely automatic fashion.
Yeah, that's right.
Thank you, Marco. Really very interesting.
Thank you.
I think we can consider your paper a frontier in machine learning in the spirit of this session.
Yeah, that's right. It was very challenging for us to.
It's very challenging. Yeah. Thank you very much. The next paper is written by Dalia Valeriani, Giuseppe Sansonetti, and Alessandro Micarelli from University of Roma 3. A paper entitled A Comparative Analysis of State-of-the-Art Recommendation Techniques in the Movie Domain. Who is here to present the paper?
Giuseppe Sansonetti.
Hi, Giuseppe. The screen is all for you. Thank you.
Very much. Okay, so consentire. Do you see my presentation?
No, not right now. No, I can see myself.
Sorry.
Okay.
Oh, great.
Okay, Giuseppe. Now I can see your presentation. Thank you.
Thank you very much, and sorry for inconvenience.
Don't worry about it, of course.
Hello, everyone. My name is Giuseppe Sansonetti from Roma 3 University. This is a joint work with my former master degree student, Dalia, and my colleague, Alessandro. The domain of interest of this research work is concerned with recommender system. In literature, a recommender can be defined as a decision strategy for users in complex information scenarios. There are a lot of examples of application of a recommender. Over the years, with the spread of recommenders, we have seen more and more proposal for recommendation techniques that claim amazing results compared to classic approach. So our goal has been to understand the real differences in performance among the different techniques known in the state of the art. So we implemented several recommendation models, starting from classic techniques up to the most innovative and recent approach. Several classification recommendation techniques have been proposed in literature according to the most general possible. Recommendation techniques are classified in three major categories based on how the recommendation is generated: content-based, collaborative filtering, and hybrid approaches. In our research work, we focus on collaborative filtering technique with reference to two different models: memory-based, which take advantage of all available data, and model-based, which exploit abstract representation of data. The collaborative filtering techniques exploits information starting from the user item matrix, namely the user item interaction. It can perform two types of tasks: prediction and open recommendation. In this work, we consider the prediction task in which we have to determine a utility function f to predict each user's preference for a new item. For the purposes of this work, we consider the root mean square error as a metric to evaluate the performance of the different models. For our experimental trials, we chose the classic movie lens 100K dataset, movie dataset built ad hoc and widely used empirical research. It consists of more than 1,600 movies, almost 1,000 users, and 100,000 explicit ratings with a value from 1 to 5 and a density of 6.3%, which means that only 6.3% of user ratings have a value.
Excuse me, Giuseppe, if I stop you. I cannot see your slides updating on the screen. I see always the first slide.
Sorry for that.
No.
Now you see?
Okay, experimental setting. Now
so I don't, okay. Sorry for that, because evidently if I put the presentation, they are not updated, but if you see this, okay?
Yes, I see it correctly, yes.
Okay. This is the movie lens dataset. We made an exploration of the dataset, first of all. For the memory-based approach, we considered the user-based and item-based approach with the k-nearest neighbor algorithms. And the similarity matrix we considered were the Pearson correlation coefficient and the cosine similarity. Differently, for realizing model-based system, we made use of a simple but effective technique called slope 1 that is based on the average rating difference between the user, matrix factorization techniques, and finally some deep learning architectures. Probably it's better to skip the results of the first experimental session we did in order to save time for more interesting findings. Anyway, you can find all details in the paper. In the second experimental session, the model was trained with different prediction algorithms based on collaborative filtering and matrix factorization, and evaluated using a k-cross-fold validation techniques with k set to 5. The most significant results are in the table. For the user-based and the item-based approach, sensitivity analysis was performed on the number of neighbors, showing the best value of root mean square error for 50 and 10 neighbors. The slope 1 model is very simple, but it allowed to us to reach a good root mean square error value of about 0.94. And the more complex singular value decomposition, plus, namely matrix factorization techniques, obtain satisfactory values. In the third experimental session, we experimented 3 different predictive models. The first one was the neural collaborative filtering that is shown in the slide. This architecture performs a preprocessing of the features in dense embedding vectors. Then it exploits neural collaborative filtering layers to generate prediction. You can see the partition of the dataset we did. The architecture we consider of neural collaborative filtering have the following structure. As input layers, we have the user ID and the movie ID as unique features. For the first model, we have one fully connected layer and one output layer. And for the second model, we have the same structure, but with addition on another fully connected layer. We obtain a root mean square error value of 0.93 and 0.992. Finally, we tested a last model based on a more complex architecture called neural matrix factorization that is based on two different deep neural networks, a standard matrix factorization network and a multi-layer feed-forward network. With the chosen configuration, we were able to achieve a root mean square error value of 0.086. All the most significant results are reported in this figure. The empirical results show how memory-based approaches are ranked the last. Although they have the advantage of being able to fully exploit the user moving data. More accurate models instead achieved more satisfactory results. Finally, deep learning models proved to be accurate, especially the neural matrix factorization model, which was able to achieve the lowest root mean square error value. We also verified the statistical significance of all the experimental results. In conclusion, in this work, we compare different predictive models. Thanks to their flexibility, deep neural networks have been shown to be able to model user-item interaction in order to capture complex patterns for the benefit of the model accuracy. So they were able to achieve better performance than classic technique, but not as much as we expected. So, according to us, further investigation are needed. In the future, we would like to evaluate the behavior of other architectures, such as recurrent neural networks, and unsupervised approaches such as autoencoders, and also to experiment other recommendation techniques in different domains, not only in the movie domains. Thanks for listening. If you have questions, suggestions, and above all, solution, please, I would be happy to answer or to hear them.
Thank you very much, Giuseppe. A very interesting review. Any question? I have a question for you. I think that recommender system is a very mature technology. Do you think there is room, space for any improvement?
Yes, there is improvement for I think for all scenarios. But I think the actual trend, the current trend, is to try to make recommendation in different domains and considering other metrics, not only the accuracy, but for instance, diversity, serendipity, and so on. So it's possible, I think there is room, but also interesting, for instance, the best paper at the Rexis conference was to understand if the recommenders based on deep learning architecture are actually better than the classic approach. And in this paper, the authors show that most of the deep learning models are not so effective as the authors claim. So I think we have to pay attention because deep learning models can be useful, but they have to be treated with caution because they also give obviously a problem in computational resource and so on.
Thank you very much, Giuseppe. So I think your opinion is that there is still a lot of space for improvement in recommender system.
Yeah,
it's a lot of work to do.
But the only thing I think, for instance, I didn't want that. I would like not that the community move under to try to to work on very effective algorithm. But I think would be interesting to integrate with the different different models and domains.
Thank you very much. Any other questions?
Thank you so much.
Okay, we are very early with respect to our timetable. If everybody agree, I should suggest to stop 5 minutes and come back here at 12 o'clock. Okay?
Thank you. Sure. Thank
5 minutes pause. Thank you.
Okay. Okay.
Thank you. Okay, we are back here for the second part of Frontiers in Machine Learning, a specialized session in ICCSA 2020 workshop. And is Giuseppe still here?
Giuseppe is here.
Okay, Giuseppe. Okay, the next paper is from Lorenzo Vaccaro, Giuseppe Sansonetti, and Alessandro Micarelli from Roma Tre University, a paper entitled Automated Machine Learning, Prospect and Challenges. Who is here to present the paper?
Yeah, because you are lucky. I will not present the paper.
Okay.
It will be presented by Lorenzo.
Hi, Lorenzo.
Good morning, Lorenzo Vaccaro. I'm going to present the paper.
Good morning, Lorenzo. It's your turn.
So I can start directly? Can you hear me?
Yes, I can hear you. Yes, I see you and I can hear you.
Okay. Can you see my screen?
Yes, I can see your screen.
Okay.
Thank you.
Good morning. My name is Lorenzo Vaccaro, and I'm going to present this work on theoretical and experimental analysis on meta-learning. So meta-learning is defined as the field of machine learning where learning algorithms are applied to metadata about experiments of machine learning itself. So it can briefly be defined with the expression learning to learn. So in metadata, we explore the architectures, the models, and the related parameters, but also the learning algorithms get recursively optimized. Two research questions closely linked to each other motivated my research path. So the first is whether repeated optimization of machine learning methods through meta-learning can improve learning efficiency. And the second research question, on the other hand, is more concerned the epistemological field. So I wonder which are the elementary mechanisms at the basis of the machine learning, but also of human learning. So we're talking about complex structures that can scale automatically. And there are several answers to this question in literature. For example, in the figure, the researcher Pedro Domingos has distinguished and classified 5 methods of inference. And my research questions is based on defining which one of these is the best master algorithm, the best for meta-learning. So that is which one learns best to infer information in complex and dynamic systems. In the first experiment, I theorized to achieve the better results in auto machine learning, a hierarchy of inference system must be modeled. So following this intuition, I developed a layer symbolist model. So each layer is a program and is responsible for optimizing the underlying layer. The lower layer is an algorithm that solves a problem, and the overlying layer is a program that generates algorithms that solve problems. So if the structure is made to evolve vertically, so if the information is inferred upstream in the hierarchy, the highest layer of this architecture can be expected to encode new learning methods, new learning algorithms. So I used an esoteric language consisting of only 8 instructions called BF, proposed by Miller in '93. And the 2 figures on the right represent 2 successive execution steps of the algorithm. And I've tested models up to 265 layers. However, you can well imagine how the complexity grows exponentially with the number of layers. So I tried to move to a more conventional approach. And in the domain of connections, the application of meta-learning is called Neural Architecture Search, or NAS. I read many publications or articles dealing with NAS, and I studied, analyzed, and experimented with the architecture proposed. And this phase was more analytical than experimental, and allowed me to understand the fundamental role of unsupervised learning, and in particular of reinforcement learning in the search for neural architectures. So the search of neural architectures, in fact, consists of modeling complex dynamic structures. In a similar way to reinforcement learning, the rewards are sparse and share long-term dependencies. The state space is very large, can contemplate both discrete and continuous variables. So in short, reinforcement learning addresses most of the problem faced also in meta-learning. So I've come to the conclusion that connectionist models alone are not sufficient to model this dynamic structure. That a property that is indispensable for the research for neural architectures. So generally, mixed methods are applied to infer these dynamic structures, which adopts different machine learning paradigms. And in fact, in the last phase of research, I concentrated on the application of alternative models to reinforcement learning. So I've tried to exploit some models where the inference mechanism is defined in different machine learning paradigms to study the relationship between learning methods. And a model that arises from the combination of the connectionist paradigm to the analogizer paradigm is the differentiable neural computer proposed by Alex Graves, DNC. And in the research work, I tried to adapt this model to apply to reinforcement learning and to the search for neural architectures. And another interesting development was the nesting of a DNC into another, which allowed me to analyze the addressing process in the connectionist analogizer models. A further model that I've used to make improvement in reinforcement learning is NALU, Neural Arithmetic Logic Units. I've introduced a bias that allows the system to instantiate constants, and I replaced the single logarithmic space with a tetrahedron function that allows the model to model an iteratively defined logarithmic space. And also explored the possibility of reformulating this model as a cell of a recurrent neural network. Lastly, I applied the Hinton capsule network reinforcement learning problem. So I've integrated this model into the deep quality network and into the actor-critic architecture. Originally, the capsules were created to model local and global relationships between graphic entities identified in an image. And they're able to perform classification tasks by decomposing the image to be detected into the subcomponents. So for example, to identify a face, it will first have to detect the nose, the mouth, the eyes. And this learning process highlights hierarchical structure in the data taken in consideration. And therefore, I modeled the actions of reinforcement learning system as capsules to reveal the relationships and hierarchies between the chosen actions. In the symbolist architecture, the results obtained are difficult to compare with the state-of-the-art for many reasons. The rush for a more canonical and therefore comparable architecture motivated my second experimental phase. In the second experimental phase, I extracted, analyzed learning and meta-learning methods. And I've experimented with meta-learning under different application contexts and identified a more specific sector for the third experimental phase. The results of the third phase of experimentation highlighted three models. I deepened the experimentation for the two models that seemed more promising to me, and the implementation is available on the work repository linked at the bottom left of the slide, and also partially reported the results in this table. So yeah, for the last experiment, I replaced the connectionist core of the actor-critic and Nichiren architecture with a capsule network. In the last column of this table, I reported the role of routing of capsule within the architecture. So for example, for vision, it meant that the capsule has the role, so is responsible for inferring the compressed representation of the state of the game given a frame. On the other hand, for example, by policy, it is meant that routing has the role of the direct role of choosing the action to be carried out by the system. So in conclusion, I can say that by concurrently applying the connectionist and the analogizer learning method, it is possible to obtain excellent results in the field of reinforcement learning and consequently in meta-learning. With the symbolist and evolutionary paradigm, it is possible to model dynamic structure, even very complex programs. However, one of the disadvantages is the low computational efficiency. The Bayesian paradigm instead has led to excellent results by adopting elementary models with simple structure. And finally, I found this model in literature, always designed by Pedro Domingos, that allows the representation of any type of information, allowing the modeling of uncertainty. And in fact, among possible future development, there is the possibility of modeling uncertainty in the proposed symbolist architecture. So by adopting this representation, the program will be analogous to a Markov logic network and consistent with the self-learning environment proposed by Pedro Domingos for the search of the master algorithm. In the field of meta-learning, I suggest as a future development to focus the research on the definition of learning and self-learning and meta-learning algorithms rather than the structural definition of neural networks. Thank you for the attention. In case you have any question, don't hesitate. I also left my email. And that's all.
Thank you, Lorenzo, for your interesting presentation. Neural architecture search is a notoriously difficult problem. Any question?
I raise my hand, but I don't know if can I
Yes,
do?
yes.
Thank you so much. Can you hear me, Massimo?
Yes, I can hear you.
I would like to ask Lorenzo, because I think Lorenzo did a very great work, also experimental work in the video game domain. Lorenzo, can you think of other scenarios where you can test such architectures?
You mean always in the reinforcement learning, so the gaming environment? Yes, of course, it can be applied to every kind of reinforcement learning problem. So actually, also the search for neural architecture is a reinforcement learning problem. So it can be modeled as a reinforcement learning problem. So it can be applied to neural architecture search, the architecture that I developed.
Such as robotics or something like that, because I think
of course also robotics it can be applied to any kind of reinforcement learning context application.
Thank you so much.
I have a question, Lorenzo. I am concerned on the efficiency of the process. What about memory consumption or inference times?
Memory consumption, I didn't really monitor the memory consumption, but usually there is a really huge trade-off between the amount of space you need to acquire to infer more rapidly into these systems.
Thank you, of course. Thank you for your interesting paper, and thank you, Lorenzo. And the next paper is from Marco Polignano, Marco De Gemmis, and Giovanni Semeraro from University of Bari Aldo Moro, a paper entitled Contextualized Birth Sentence Embeddings for Author Profiling. The cost of performance. I can see Marco again. So
yes, I'm here again.
So to you.
Okay, thank you. Okay, hello again to everybody. And I'm here today for presenting this paper about contextualized birth sentence embeddings for author profiling the cost of performances. So what is the task of author profiling? The task of author profiling aims to find, to guess what are the characteristics of an author. So a person that publish something on the internet, like a post on social media or a news or a journal article, with the purpose so the idea is to guess the characteristic of this person in order to support companies and so on for profiling their customers and decide how to move on the market their product and made statistics and so on. So this kind of problem has been largely investigated by the research community. As we can see from this slide already from 2015, many datasets about author profiling have been released, but we can observe that each dataset decide what feature to investigate. So sometimes we have the age, the gender, the occupation, and so on, but other times we have also other different kind of characteristics, such as emotion, personality, education, and so on. So for this project, we decided to focus on one of the last datasets, the celebrity profiling dataset that was released the last year at the CLEF conference. And the dataset is about tweets written by celebrities. And it is important to note that this dataset is very accurate because all the information about the fame, the occupation, the birthday, the gender of the celebrities are public information that could be easily found on Wikipedia and so on, and consequently this kind of notation has been very accurate. So what was our idea? Our idea was to try to start with the encoding of the tweets written by these celebrities. And for this step, we decided to use BERT. BERT is a bidirectional encoding transformer architecture that has been released last year by the Google Research Laboratory, and now it is largely used in many research. We decided for this research to use a quite different architecture for encoding the sentences into word embeddings, that is BERT-SE. This kind of model is different from the classic BERT because it has been fine-tuned using Siamese network on a dataset where the entailment among sentences has been annotated, and consequently the result of this architecture are word embeddings of sentences that are very suitable to be compared through similarity measures like cousin similarity and so on. Moreover, this model is very computationally efficient. It needs only a GPU for the encoding, and consequently we decided to use it. Then the output of this model has been used in a deep neural network, that is the one on the left side of the slide. The architecture is composed by a BLSTM as first layer. Then on the output of the BLSTM, we are applying a self-attention layer, and the output of this layer has been used by a convolutional neural network that allows also to encode not only the correlation between words, but also inside each embedding that represents the specific word. Then we have a concatenation layer that tries to concatenate the output of BLSTM with the one with CNN. And finally, we have some layers with the softmax that allow us to make the prediction of the specific characteristic of the user on which we are focused. Then we tried to evaluate this model. We use the same dataset that I described before. It contains more than 6,000 of celebrities for training, more than 2,000 celebrities for the test, and for each celebrity we had around 150 tweets. And it is important to observe the dimension of the dataset because it is quite big, and consequently we decided to implement it on Google Colab, which provide us 25 gigabytes of RAM as GPU and a TPU, and unlimited disk space. Moreover, we also implemented some baselines. The first one is the SVM plus linear regression, that is the winning strategy of the challenge in 2019. And after that, we tried also the random forest, which was the second classifier. So the results about F1 score can support our idea that the model is very performing if we are considering the accuracy of the model. And for example, about the gender, we have an F1 score of 0.89, that it's a quite high score. But I think that it's important to focus more on this slide because, yes, the value it's high, but also the value that we obtain with the SVM and linear regression is not so far. We are talking about a 0.02 point of difference. So what we would like to invest more was the trade-off between accuracy and computational cost of the model. And consequently, we start investigating the time that we need to encoding the sentences. We can say that our strategy that uses BERT-SE, when we reach the total amount of sentences inside our dataset, more than 1,000,004 more or less, we spend in total 33 hours of computation. While if we want to encode the dataset for the previous strategy that I said, SWM plus linear regression, that use a TF, classic TF IDF score, we need only 1 hour, also less sometimes. And a similar strategy we adopt for measuring the quantity of RAM need for running this algorithm. And as we can see with the TF-IDF, we need only 100 megabytes of RAM, comparing it with the amount of RAM used by BERT, that is around 15 gigabytes. For what concerns the learning time and the prediction time, we can say that, okay, our model is fast compared to the other baseline, but we can say that here the architecture is different, because here we are using a TPU that is a novel, we can say, architecture that is largely used by Google Research, that it is claimed that it is more than 100 times faster than a CPU. So we need a very expensive hardware for running the model. Similar, we can say, moreover, we can say that also the prediction time, it's very fast. We need only 12 seconds. What about the RAM? About the need of RAM is also in this case very high, because our model needs to keep in memory all the BERT pre-training model and so on. So concluding, I would like to focus on what we observe. That means that, okay, our model, our new models, you know, like BERT and transformers and so on, are often more performing than classic machine learning approaches. But we need also some time, especially when we apply this strategy in a real domain, to consider what is the trade-off between cost and performances, because sometimes, probably for 0.02 points of F1, it could be useless to use a so much powerful model, and we can do more or less the same thing with an architecture more simple that can run on every laptop and PC that we can find everywhere. That's all. Thank you.
Thank you very much, Marco. Also, this presentation very interesting. Any question?
Yeah, it's Giuseppe. Can I do a question?
Yes.
Thank you so much. Ciao, Marco.
Ciao.
Thank you so much for your great presentation. You try, you make a comparison with support vector machine and random forest.
Mm-hmm.
Did you think of try to compare with other BERT with other generic sentence encoders such as Elmo or Use or if%?
Okay. No, I didn't try this, but the purpose was to try to see the differences between a classic model and a novel model, because we know that also Elmo is more or less quite performant like BERT. So also in this case, okay, we need probably a little more time, a little more memory for run the model, but we are more or less we are talking about models that needs a GPU or an expensive hardware for running. So that's why I didn't do this this comparison, but for sure it could be nice to have this statistic for the future.
Thank you so much.
I have a question, Marco, a question at the boundary of your paper. What is your opinion about the efficiency of Google Colab? Because I can see very contrasting opinion. What is yours?
Yeah, I'm using actively Google Colab, sometimes also with the free account. And for the free version, we have limits about the resources that they provide to us, and consequently, yes, okay, it's efficient, but not so much. But
you have to pay for the efficiency.
Yeah. I'm using for training BERT from scratch Google Colab. We have a sponsorship, so we have some free credits, and with the paying version, we are working very well.
Thank you very much, Marco. Any other question? Thank you very much. Now I'm gonna to share my screen because I will be the relator of the next presentation. Okay. Can you see the presentation?
Yes.
Okay.
Yes.
Can you hear me?
Yes.
Okay, thank you. A paper from Luigi Santacroce, Andrea Ballini, and Massimo Bilancia from University of Bari, and Sara Mavaddati, and Javada Mehdi and Baman Zeinali from University of Tehran. In this paper, we are going to talk about microbiome, which is the collection of genomes from all the microorganisms found in a particular environment. In particular, we are going to talk about good microbial communities, because it has been demonstrated that good microbial communities has important association with overall host health. And in particular, we are interested in distinguishing patients at high risk of life-threatening post-transplantation conditions, like rejection, infection, and other life-threatening conditions. In this paper, we have applied topic models to identify those bacterial species that have the most important weight under the two different experimental conditions, such as pre and post transplantation or healthy controls and transplanted patients. Why using topic models? Because topic models are essential a class of dimensionality reduction. The biological structure of gut microbiota is very complex, and using topic models, we are able to identify the bacterial species that have the most important weights. Bayesian topic models, this is even more important, are not affected by data scarcity. We have at present very few data, and the conclusion we can draw borrows strength about a very sparse microbiome sample, and allow comparison with a baseline of a pre-transplantation condition, even in a situation of scarcity of data. We considered two data sets concerning liver transplantation. In the first transplantation, 703 samples from 175 patients, and we considered pre-liver transplantation data and post-liver transplantation data in a period from month 6 to 12 after transplantation. A second data set is a study in which were enrolled 90 liver transplantation recipients in the treatment group versus 61 healthy controls in the control sample. In both studies, no significant difference existed between the two groups in terms of age, sex distribution, and body mass index. In particular, a particular target gene sequence was amplified from each extracted DNA samples to characterize the bacteria, to identify the bacterial species. Why using topic models? The main input to topic models is the term document matrix, in which we have terms on the rows and documents from a corpus on the columns. How can we translate term document matrix in the context of gut microbiota studies? Well, OTU, organized taxonomic units, that is a single bacterial strain, can be interpreted as terms. Samples can be interpreted as documents. Corpus is the set of all fecal samples associated with the environment. the gut in our case, because we are concerned with gut microbiome. And so we had, after this mapping, after this transformation of semantics in which terms and documents are mapped onto organizational taxonomic units, sample and corpus, we had two terms document matrix that must be reinterpreted in this sense. So we had two very large term document matrix for both dataset 1 and dataset 2, describing the abundances of each organizational taxonomic units. And the topic model we used is quite standard in machine learning and natural language processing communities. That is latent Dirichlet allocation, because we know that latent Dirichlet allocation consider each document as a mixture of topics, and of course each fecal sample contains a mixture of bacterial communities that latent Dirichlet allocation may contribute to disentangle. Latent Dirichlet allocation is a generative model. We have a likelihood in which we have a multinomial likelihood for the occurrence of term, and a latent variable which describes to which topic each term belongs. And also we have the vector theta d, which is the vector which describes the frequency of occurrence of each topic in a document. We use, of course, the main issue with latent Dirichlet allocation is setting the number of topics. We considered three methods to compare out of sample the godliness of fitness of the latent Dirichlet model with varying number of topics, with k ranging between 2 and 60, with a step, with a varying step. And now let's see together the result of this preliminary study, because this is the first time that latent Dirichlet allocation has been applied to the context of gut microbial communities. First, dataset 1. As you can see, we have an optimal number of topics, which is 15 for pre-liver transplantation and 30 for post-liver transplantation. Dataset 2, K uguale 15 for healthy controls e K uguale 35 for transplanted patients. In both cases, the curve presents an aspect that's very similar qualitatively, but what is most intriguing is that the optimal number of topics is much lower in pre-transplanted patients. We should argue that liver transplant always increases the diversity and the richness of microbial communities. And this aspect is not always captured by traditional indices of diversity. But topic models are able to conclude that the diversity of microbial community is increased after liver transplantation. Second, which are the most likely topics? We use two traditional methods. First, topics were sorted according to their global probability of occurrence on the entire collection of samples. And topics, second method, were sorted by counting how often a topic appeared as a primary topic. The second method is traditionally known as rank 1. And but as you can see at this point, we have only a collection of topics from the most likely to the less likely. But what we can do is we can plot the top 10 terms for each data set. So you can see this, for example, for dataset 1 for pre-liver transplant, these are the probability of occurrence for the 10 top terms for the 5 most likely topics. And as you can see, the microbial community have been expressively mapped. We are now able to understand which are the bacterial species which are most frequently occurring pre or post liver transplantation. So this is a very expressive analysis, which is impossible, for example, using traditional instruments such as meta-analysis, because as you can see, dataset 1 pre-liver transplantation, the picture changes completely after liver transplant. Same situation for dataset 2, controls and post-liver transplantation. So our results are still experimental. Topic models are really useful to analyze variation in gut microbial communities, and the analysis can be carried out at a level which is very close to natural languages, and that can be easily interpreted by clinicians. And we have also dynamic version of topical models, so that microbial dynamics can be tracked and followed over times. And we hope that this could help in monitoring post-transplantation phase for prescribing the best treatment options and prevent life-threatening condition. This is the essential bibliography for our paper. Thank you for your attention, and I must... okay, I'm here again. Any question? Okay.
I have a question. Sorry. Thank you so much for your great talk. I'm sorry because I am not familiar with this scenario, but it's very interesting. Only a curiosity: did you try also other dimensionality reduction techniques?
Yes. Thank you for your question.
Like the classic ones, TSNA and so on.
No, thank you for your question. Your question is very interesting because we tried only latent dirichlet allocation, but we are going to try other techniques based on singular value decomposition, for example.
Yeah, the classic one.
Because we want to compare the result from latent dirichlet allocation and the result from matrix decomposition techniques such as SVD. So we want also try dynamic version of traditional methods or correlated topic model, which are able to construct cluster of microbial species. So I think that this is a very interesting field to work on, and I hope that there will be further developments, and the final objective is to build an instrument which can be used in a clinical context. Thank you, Giuseppe.
Thank you so much. Thank you.
Any other question? Thank you. Okay, so let's go ahead. A paper from Alex Haro, Giulio Toalombo, Eddie Galarza, and Nancy Guerron from Universidad de las Fuerzas Armadas, Sangolquí, Ecuador, a paper entitled Detection of Thyroid Nodules through Neural Networks and Processing of Echographic Images. Who is here in the room to present the paper? We are early, so it's very likely that no one is still present in the room, because this was part of FEMUR 3.
We can wait.
We have to wait. I suppose we have to wait.
Yeah.
I suppose we have to wait 20 minutes.
Yes, I suppose to.
Okay. See you 20 minutes in 20 minutes here. Okay?
Perfect. Okay, thank you.
Thank you.
Thank
Thank
you.
you.
Okay.
Okay, we are here again.
Okay.
Okay. So just a moment. So the last part of our session, Frontier in Machine Learning, and it's the turn of a paper presented by Alex Aro, Giulio Palombo, Eddie Galarza, and Nancy Guerron from Universidad de las Fuerzas Armadas, ASPA, Sangolquí, Ecuador, a paper entitled Detection of Thyroid Nodule Through Neural Network and Processing of Echographic Images. And who is here to present the paper? I see you, Alex.
Hi.
Hi, Alex. The screen is
Welcome.
all for you. Thank you.
Gracias. Thank you. Um,
Thank you. We can see you, your presentation, and we can hear you correctly.
Yes. Welcome. My name is Alex Aro, and my research topic is detection of the thyroid nodules through the neuronal networks and processing of the echographic images. Outlined. Introductions, materials, and methods. The general scheme of the development system, definition of requirements and parameters, proposal implementation, experimental results, Python and TensorFlow test, conclusions. Introduction. The thyroid nodules analysis, errors in imaging resolutions of contrast, inadequate treatment can combat this health problem. The problem, use of technology tools for early detection in neuronal networks. Material and methods. The system includes the following step storage of ultrasound imaging. Imaging is the database. Processing only in the Python. Convolutional neuronal network. Subsequent treatment of the information. In the imaging is the presence the thyroid ultrasound imaging servers, imaging pre-processing, convolutional following, multiplayer neuronal network, Somax overlayer, and finishing in Jupyter and Python. Requirements using Python and TensorFlow. Important of imaging stored in the database. The parameters specify imaging size, number of the images, processing sets, and convolutional filters. Proposal implementation. The detection of the nodules is carried out by using a convolutional neuronal network strategy that mimics the visual cortex of the humans aids to identify objects. The better the capacity of the computer, the better functionality is obtained. Software. In the software, SPDAD, Anaconda Navigator, Jupyter Cares. Experimental results. The result was obtained percentage of the presence of thyroid nodulus according to age range in young, adults, elderly. Percentage of presence of thyroid nodules according of general in the man and woman. In the woman, the present more nodules, thyroid nodules. Thyroid nodules detection per software. Detection of the thyroid nodules in the Python. Parameters if the presence of nodules, yes or no. The size in millimeters. Thyroid nodules detection per software and in the parameters yes, no, in size in millimeters. Test results from the Python with 100 images. True diagnosis. The true positive, true negative, and total. True positive presents 50, absence 4, total 54. True negative 2, absence 44, in total 46. In total, the presence is 52, absence 48, total 100. The sensitivity is 96.15. Specificity is is 91 and 67. The positive predictive value is 92 and 59. Negative predictive value is 96.65. The test result of the test result from TensorFlow with 100 images, the true diagnosis. True positive, true negative, total. True positive. Presence 49, absence 6, total 55. True negative. Presence 3, absence 42, total 45. Total presence 52 and absence 48. The total 100. Sensitive 94, point 23. Specificity is the 87.50. Present 89.09. 93 and 33. Conclusion. Within an diagnostic of the terror nodules, pathology phase consists of the analysis of the exact tissues, and the clinical phase consisted of the executions of medical examination and imaging study. The system has been designed to be able to identify nodules of the 4 millimeters in size. This can be malignant or begin when a nodule is detection is must be following of analysis to determine if this malignant. Antecedents can 11 to a malignant nodule art, rapid growth of the module, student and recent charge in voice difficulty, shallowing or breaking palpitation of the nodules as a hard mass or invalid needs nodules. In this application, Python is a programming tool that of the working reliability with sensitive of 96.50 and specified and 91.67. In TensorFlow, reach less valued 94.23 of the sensitive and 87.50 for specificity. However, it should be considered that application will only 500 images and 100 of the her destination that test this investigation. So if the convolutional neuronal networks, the training with the large database, the result might vary. The object of the research is not the establishing and the direct diagnostic in the Pythons, but to convince an useful tool for speciality to allow to determining with greater certain presence of entire nodules and additional to provide approximating information on her size. Applications.
Excuse me, Alex, 1 minute.
Yes.
You have 1 minute more for concluding your presentation.
What?
You have since the presentation must be take 8 minutes in total. You have
yes.
1 minute to conclude your presentation. Thank you.
Thank you, the presence.
You have one more minute. Okay. Thank you, Alex, for your interesting presentation. Any question?
Thank you very much.
Any question? Yes, I have a question. What about the applicability of your proposal in a real clinical context?
The real clinical context is and your better detection than thyroid nodules for the medical and puedo hablar en mi idioma, no sé si es que me entienden, no sé cómo explicar esta idea.
Okay.
Bueno, ¿cómo les explico? El contexto más de la aplicación que va es una mejor dirección de la detección de nódulos tiroideos, más no solo en la visión del doctor, sino ya en una inteligencia computacional para poderla determinar con mayor rapidez y esto seguirá aumentando con un mayor entrenamiento de la red neuronal.
Your main objective is not diagnosis, but screening, individuation of nodules.
Exactly.
Thank you for your very interesting presentation, Alex. Any other question? Thank you, Alex. Last but not least, a paper from Ochilbek Rachmanov, Nile University of Nigeria, a novel algorithm to classify hand-drawn sketches with respect to content quality.
Good afternoon, Prof.
Ochilbek, are you here?
Yeah, you can. Can you hear me?
Yes, I can hear you, but okay. I can hear you, I can see you.
All right. Good afternoon, Prof.
All for you.
Good afternoon, everyone. Let me share my screen.
Thank you. Okay, we can see your presentation.
All right, Prof. Okay, good afternoon all. Today I will present a novel algorithm to classify hand-drawn sketches with respect to content quality. I am participating from Nile University of Nigeria. So the importance of hand-drawn sketches are getting very popular as today we are using many of devices which we can touch, we can draw on them, and it seems that we will have more devices where we can sketch the stuff. So that's why recognition of the hand sketches is popular topic now. In 2012, ICCSA released a dataset which consists of 20,000 images of 250 different objects. For consecutive 7 years, mostly these datasets were used to develop a classification algorithm by many researchers. So in here we see a sample pictures from that dataset. We have chairs drawn by the hands, we have butterfly, pigeon, and bicycle. So mostly for recent 7 years, this dataset was used, and the main idea was to classify them. Like this is chair, this is butterfly, this is pigeon, and so on. Different classification techniques were tested by the researchers. Image feature extraction techniques in computer vision were also a major player during the researches. So as we can see from the literature review, usually what the researchers they used SVM and CNN as a classification tool. They also used a histogram of gradient orients and SIFT and star graph to extract the features from the pictures, and bag of visual words were also employed successfully. Now, this is how to separate different objects. But what if it comes to content quality? Let's address what's the content quality. Content quality might be defined as content that delivers the value. So if you look at this picture, we see a face. This is face, and this is also face. And we see a bicycle. This is bicycle, this is bicycle, and this is bicycle. But the problem is in here, the quality of the picture. As you see, the features are very small in here. The number of features is in medium level. In here, number of features is high. So the problem is how good are the techniques when it comes to classification with respect to content quality. How the classification algorithms will behave if we try to classify them with respect to their content quality. This issue is very important in psychology and education. Like in psychology, they're giving the test to the children and they're asking them to draw the pictures, and from those pictures they're concluding some conclusions like how to work with the kid, what kind of test they should adopt, and so on. So to address this issue, to develop a methodology for content quality, we selected draw a person test. What's the draw a person test? Draw a person test is a skill test that is designed to measure a child's mental age through the figure drawing test. So we are just giving a piece of paper to the child and asking to draw a man. So in here you see some samples from our data set. So this is the picture which belongs to a boy 5 years old. This is a picture of 7 years old. This is a picture of 9, and this is a picture of 10 years old guy. So the task in here is clear. We need to develop a classification algorithm which can classify these pictures according to the ages. So a data collection procedure was done by experts who are expert in this field in psychology and education. The scoring of the images were also done by the experts. So this is our data set. We have almost 1,000 images classified into 8 different classes. This is 4 years old, 5 years old, 6 years old, 7 years old, and so going on. So this is our data set one, all 8. We call it all 8 because it's divided into 8 classes. During the experiment, we saw that it's very difficult to classify them. That's why we produced a second data set, which we call double. In double, we joined the adjacent ages 4, 5 years old, 6, 7 years old, 8, 9 years old, and 10, 11 years old. By the way, since these 10, 11 years old pictures are the best ones, in here we see the picture, we call it a reference data set during development of our algorithm. The problem with this data set is clearly explained in this picture. If you look here, these two shapes, they're completely different, but they belong to a class of 4 years old kids. These two pictures, they're completely different, but they belong to same class of the kids. These pictures, they, as you see, they're different, but they belong to same class of. So actually, to classify this data set is very, very difficult because very small number of similarities in here. Like you can't just look at them like chair, or butterfly. As you see, the number of features, the features, the visual effects are important in here. So we tested the common use state-of-art techniques. So we used SVM and histogram of gradient orients and tries to classify it. So all 8 data set was successful only with 22% of prediction accuracy, while double was 48. We also tested CNN with proposed state-of-art methodology, and the classification for all 8 was 32, and double was 52% test accuracy. So as you see, the state-of-art methodology couldn't understand the dataset. That's why we had to look for the new methodology. For this methodology, we call it SKP algorithm. The SKP algorithm stands for Counting Key Points algorithm. So this is the waterfall of how the algorithm works. I will go simply from this picture. We are taking a picture. We are finding the key points. Like we are finding 1,000 key points and calculating their descriptors. We are finding 1,000 key points and calculating their descriptors, and doing for each image like this. Then if we are choosing 1,000 images, like we are making k-mean for 400 key points and finding most commonly appearing 400 key points. So this is the result of initial study. So for every class, you see we calculate the mean and standard deviation. So as you see, the mean is increasing. With the increase of age, the mean of key points is increasing. And we test 4 different sets, and the best behavior set is this one. Like when you're choosing 2,000 key points and you are finding 800 similar key points among them using k-means. So as you see, the means is continuously increasing in here. So this is automatically, same in here, this is automatically pushing us to the hypothesis that we can classify these pictures using these means. So next, we are developing a system where we are putting limits, like for this one, for set 4, if number of key points is less than 145, then it belongs to 4 years old. If it's less than 165, then it belongs to 5 years old. If it belongs less than this number, then belongs to this one, and so on. Samely, we did for double data set. If it's less than 164, then it belongs to 4.5. If it's less than 194, it belongs to 6.7, and so on, going on. So, and lastly, using this limit, using this manual limit, we are testing our data sets. So we are testing for each class in here, and as you see, set 4 is behaving best, and producing the highest accuracy for all 8 data sets. This is all 8 data set, and the prediction accuracy is in here is 0.57, so 57% of prediction accuracy. While for double data set, this is 4.5, this is 6.7, this is 8.9, this is 10.11. We see that prediction accuracy is higher. It's expected to be higher, so the prediction accuracy is 65%. So if we compare to the state-of-art methodologies, we can clearly see that SKP is overcoming the state-of-art methodologies. It's giving higher accuracies, but still the accuracy is not very high. And the main problem in here is, like I said, the shapes. The shapes can be very different, and the data set is very difficult to classify. But we believe with further studies, we can improve this 65% of prediction accuracy. And this is all our references we used. Thank you. If you have questions, sir.
Thank you for your excellent presentation. And any questions? I have a question for you.
Yes, please, Pro.
Which are the main application of your work? For example, I suppose the diagnosis of mental development disorders?
Yes. Like, let me give you a simple example. When you're telling a child to draw a man,
yes,
assume that a child is 10 years old, and the methodology says that the picture he drew is 7 years old. Then this means that the practitioner should understand that he should work with the child, because the mental development of the child is not yet ready. But this is done manually. The practitioner should look at the pictures manually. What we are trying to do in here is to develop a computational device, a methodology, which we can classify the picture automatically.
Yes, thank you very much. Very clear presentation. Any other question? Okay.
Thank you, Prof.
Thank you. Thanks to everybody. Frontiers.
I've got one question, sorry.
Okay. Excuse me, please.
Yes, please.
Thank you. I wonder if your algorithm would manage to classify objects when there are more than one in an image. For example, the task for a child is to draw a holiday, the best holiday ever. And would it be all right with your algorithm to classify the age of the child?
Yes, very good question. The issue in here, what you're asking is generalization of the algorithm. To generalize this algorithm, we need to try it on different data sets. Like, we need to test it on data set where the kids, we ask them to draw trees, or we ask them to draw a car to understand their mental age. And we need to test this algorithm on different data sets. Then we can generalize it. For now, it's specific for this data set. And the next step for further research is to generalize it.
Okay, thank you very much.
Thank you.
Any other question? Any other question? Okay. Thanks to everybody. Frontiers in Machine Learning 2020 ends here. And thank you for your work. Thank you for your excellent presentation and papers. In a few days, all papers will be published on the lecture notes in computer science proceedings. And hope to see you back from ICCSA 2021 by live, not by screen. Okay? Thanks to everybody.
Thank you, Massimo.
Thank you.
Thank you.
Bye.
Thank you.
Thank you very much.
Thank you very much.
Mr. Chairman, I remember you the evaluation form. Thank you.
I compiled all the forms except
Thank
mine.
you very much.
Except mine, of course. Except the form regarding my paper. Okay.
Thank you
See
very
you.
much.
Thank
See
you.
you. Bye-bye.
See you.
Bye.
Bye.